Hey everyone! In this week's episode, we'll talk about the most popular and commonly used programming language, Python. So let's begin and learn about the development of Python and gain insights about the current IT trends. But before that, make sure to subscribe to our channel and hit the bell icon to get notified every time we come up with new content. Python is very famous for its simple programming syntax, code readability, and English-like commands that make coding a lot easier and efficient. Due to this, it is the most popular and preferred language. Python is an interpreted, high-level general-purpose programming language developed by Guido van Rossum at National Research Institute for Mathematics and Computer Science, Netherlands. In contrast to popular belief that Python was named after the snake, Python was actually named after the show Monty Python's Flying Circus. Guido van Rossum formulated Python in the late 1980s as a successor to the ABC language. In 1994, Python version 1.0 was released with features like exception handling, lambda, map, filter, and reduce. Python 2.0, released in 2000, introduced features like list comprehensions and a garbage collection system capable of collecting reference cycles. Python 3.0 was released on the 3rd of December 2008. Undoubtedly, Python 2.x and 3.x have proven to be the most used versions. As of today, Python 3.7.4 is the latest stable version released in the summer of 2019. Python is popularly used for development, scripting, and software testing. Top IT companies like Google, Facebook, Instagram, Spotify, and Netflix, among others, use Python. Some major applications of Python can be seen in the fields of machine learning, artificial intelligence, data science, and IoT. Python also offers many libraries like NumPy, SciPy, Keras, TensorFlow, Django, and Flask. Pep 8 is the official style guide that defines the styling conventions for Python code. A few popular open-source Python projects include pipenv, Chatistics, solving the traveling salesman problem using self-organizing maps, and Python to BPF converter. Some of the trending Python repositories on GitHub today include NLP, ML from scratch, PyTorch transformers, 100 days of ML code, among others. Popular websites on the internet like Reddit and Quora are built using Python. Civilization 4, Battlefield 2, Sims 4, and World of Tanks are some popular games developed using Python. According to Indeed, the average salary of a Python developer in India is about 5 lakhs per annum, and that in the US is around $124,000. Users and admirers of Python, especially those considered knowledgeable, are referred to as Pythonists, Pythonistas, and Pythoneers. Since its inception, Python has come a long way to become the most popular coding language and continues to revolutionize the IT industry.
Python is a widely popular programming language that is used for web development, game development, data analysis, as well as data visualization. Hi everyone, welcome to this Python Developer Full Course by Simplilearn. In this session, we will cover all the important Python concepts, techniques, and projects that will help you become a successful Python developer. Our highly experienced trainers will take you through this live session. But before I begin, make sure to subscribe to the Simplilearn channel and hit the bell icon to never miss an update. So we will start by learning the history of Python and understand the top 10 reasons to learn Python. You will look at the job role of a Python developer, the skills they need to possess, and how the resume of a Python developer should be. Then, we will see how to install Python and the Anaconda distribution of Python. Then we will shift our focus towards learning the basics of Python such as data types, variables, operators, lists, tuples, and dictionaries. Next, we will understand about loops and conditional statements. After that, we'll get an idea about object-oriented programming concepts and functions in Python. We will also cover some important advanced Python programming concepts such as iterators, modules, generators, as well as packages. Finally, we will see the important Python interview questions that are often asked. So let's get started.
Let's begin and learn about the development of Python and gain insights about the current IT trends. Python is very famous for its simple programming syntax, code readability, and English-like commands that make coding a lot easier and efficient. Due to this, it is the most popular and preferred language. Python is an interpreted, high-level general-purpose programming language developed by Guido van Rossum at National Research Institute for Mathematics and Computer Science, Netherlands. In contrast to popular belief that Python was named after the snake, Python was actually named after the show Monty Python's Flying Circus. Guido van Rossum formulated Python in the late 1980s as a successor to the ABC language. In 1994, Python version 1.0 was released with features like exception handling, lambda, map, filter, and reduce. Python 2.0, released in 2000, introduced features like list comprehensions and a garbage collection system capable of collecting reference cycles. Python 3.0 was released on the 3rd of December 2008. Undoubtedly, Python 2.x and 3.x have proven to be the most used versions. As of today, Python 3.7.4 is the latest stable version released in the summer of 2019. Python is popularly used for development, scripting, and software testing. Top IT companies like Google, Facebook, Instagram, Spotify, and Netflix, among others, use Python. Some major applications of Python can be seen in the fields of machine learning, artificial intelligence, data science, and IoT. Python also offers many libraries like NumPy, SciPy, Keras, TensorFlow, Django, and Flask. Pep 8 is the official style guide that defines the styling conventions for Python code. A few popular open source Python projects include pipenv, Chatistics, solving the traveling salesman problem using self-organizing maps, and Python to BPF converter. Some of the trending Python repositories on GitHub today include NLP, ML from scratch, PyTorch transformers, 100 days of ML code, among others. Popular websites on the internet like Reddit and Quora are built using Python. Civilization 4, Battlefield 2, Sims 4, and World of Tanks are some popular games developed using Python. According to Indeed, the average salary of a Python developer in India is about 5 lakhs per annum, and that in the US is around $124,000 US. Users and admirers of Python, especially those considered knowledgeable, are referred to as Pythonists, Pythonistas, and Pythoneers. Since its inception, Python has come a long way to become the most popular coding language and continues to revolutionize the IT industry.
So what really is Python programming language? Python is an object-oriented, high-level programming language that supports built-in data structures and dynamic semantics. It supports multiple programming paradigms such as structured, object-oriented, and functional programming. Python is often described as batteries-included language because it has a comprehensive collection of standard libraries. Python supports different modules and packages, which allows program modularity and code reuse. Python was developed by Guido van Rossum, and its implementation started in December 1989. Python 1.0 version was released in the year 1994. Python 2.0 came out in October 2000, while Python 3.0 was released in December 2008. Now that you have got an understanding of the Python programming language, let's now look at the top 10 reasons why you should learn Python. So at number 10, we have ease of use. One of the most common reasons to like Python is that it is quite easy to learn and code. It provides a simple syntax that improves readability and makes it easier to understand. So developers can create any desktop or machine-based application using this language. Python is very versatile and is instrumental in artificial intelligence and machine learning. We will talk about this later in the session. Compared to Java or C++, it has fewer lines of codes. In the example here, we are printing a Hello World program in Java. As you can see, if you have to write a program in Java, you first have to declare the class name along with its scope. Next, using curly braces, you need to pass the main method along with its arguments. And then, using system.out.println method, you can print Hello World. That's quite a tedious task, isn't it? The same task of printing Hello World can be done using just one line of code in Python, as shown here. You can write the print function and pass whatever you want to display inside the brackets, and that will print the output. It is so simple. That is why Python is considered as a high-level language and it's open source. You can just download it from the website and start using it. At 9, we have active community. You need a community to learn new technology, and friends are your best asset when it comes to learning a programming language. Python has large community support. It has an extensive and active community to assist engineers, developers, analysts, and data scientists with expert support in case of programming errors or issues with the software. You can just go ahead and put your queries in the community forum. The community members will address your queries in real quick time. Communities like Stack Overflow also brings many Python experts together to help learners. Python Enhancement Proposals, or PEP, is where the proposals and the improvements are announced. Also, there are a set of recommendations or core values called the Zen of Python, written by Tim Peters, that represents the guiding principles for Python development. Up next at 8, we have portable and extensible. Multiple cross-language operations can be performed effectively because Python is portable and extensible in nature. For example, if the users have a Python code written on Windows and they want to execute on a Mac operating system or Linux operating system or Solaris, they can easily do it without any amendment. They can also run this code on any platform flawlessly and without any interrupt. Due to its extensibility feature, you can integrate other programming languages such as Java, .NET, C, and C++ codes with Python. The components of other programming languages can be used with Python, and thus it can be used to make a cross-platform suitable application too. So it is a really good feature that Python provides. The next reason to learn Python is testing frameworks. Python supports several built-in flawless testing tools and frameworks that help in debugging and speeding up workflows. Some of the tools and frameworks supported by Python are PyTest, Selenium, and Splinter. This is the reason for which every tester tries to use Python-based tools and frameworks to test any application or code or to validate it in an easier manner. PyTest is the most recommended testing framework for functional, integrational, and unit testing. You can run Selenium test scripts using Python programming language to automate various tasks. And Splinter is an open source tool for testing web applications using Python. It lets you automate browser actions such as visiting URLs and interacting with their items. At number 6, we have libraries and packages. Another reason why Python has become so popular in the industry these days is that it has a massive collection of libraries and packages that make your task simple and easy. It has a range of libraries, packages, frameworks, and modules for data manipulation, statistical calculation, web development, machine learning, and data science. Python programmers have developed tons of free and open source libraries that you can use. You can find many of them via Python Package Index, the repository of Python software. Python provides the default package called pip. Anaconda is a third-party Python ecosystem. Other examples include NumPy, SciPy, and Django. Then we have scripting and automation. Python is not just a programming language. It can also be used for writing scripts for automating tasks and workflows without human intervention. The code can be written in the form of scripts and executed later. Further, it is interpreted by the machine and checked for errors at runtime. The machine is used to read and interpret the code. Once the developer checks the code, it can further run or be used several times without any interruption. This allows you to automate a set of certain tasks within a program, or the same code can be used with other applications as well. At number 4, we have web development. Another reason to learn Python is that it makes the web development process so much easier. It provides a wide collection of frameworks that make it easier for developers to develop web applications. Some of the examples are Django, Flask, Pyramid, TurboGears, CherryPy, etc. These frameworks are written in Python, which makes the code a lot faster and stable. The task which used to take hours in PHP can be finished in minutes using Python. Python is also used for web scraping. Django offers many elements of intricate programs such as template design, management panel, signing in, signing up, signing out, URL routing, etc. Once the user establishes the framework, all these features become ready to use. Flask is a microwave framework written in Python. Of all the components that are part of this module, they are all ready to execute in the server context. Pinterest and LinkedIn use Flask. Pyramid offers more attributes than Flask. It will assist users with URL routing and authentication support. TurboGears is a highly recommended and scalable framework that supports features such as authentication, caching, identification, management of sessions, and pluggable applications. Up next at number 3, we have machine learning. The growth of machine learning has been phenomenal in the last 5 years, and it's rapidly changing the world around us. Python is one of the most preferred programming languages for machine learning because of its simple syntax and support for several machine learning libraries. Using different libraries and functions in Python, the system can learn and train itself from past data. Once the system is trained, it can then learn to adjust itself to new inputs. Finally, it can make predictions and perform human-like tasks automatically. At number 2, we have data science. Machine learning and data science go hand in hand. Python is robust, scalable, and provides extensible visualization and graphics options. Hence, it is widely used in data science. Python has libraries such as NumPy for numerical computation of data, Pandas for operations to manipulate data on numerical tables and time series. It also provides SymPy for symbolic computation and SciPy for technical and scientific computations. It has another library called PyBrain, which is sought for Python-based reinforcement learning, artificial intelligence, and neural network library. Scikit-learn is the machine learning library for creating classification, regression, and clustering algorithms. And finally, it provides PyTorch and TensorFlow for deep learning. Finally, coming to the most important and the top reason to learn Python, which is career opportunities and salary. Python language provides a variety of job opportunities and promises a high growth graph with huge salary prospects. It is being used by most of the tech giants. Industry leaders using Python are Amazon, Google, Facebook, IBM, NASA, Netflix, and YouTube. Next, you can see the Google Trends, where I have considered 3 programming languages, Python, Java, and C++. I have compared them for the past 12 months. You can see it clearly on your screens that Python has become a frontrunner in terms of popularity and web search volume. It means people are interested in Python, they want to learn it and use it in their work. You can also check for the YouTube search. There also you will find that Python programming language is the most searched language on YouTube. Now on your screens, you can see the report of PYPL, which is Popularity of Programming Language Index. It is created by analyzing how often language tutorials are searched on Google. It is a leading indicator. The raw data comes from Google Trends. The bar graph depicts that Python is the most popular and widely used programming language across the globe, followed by Java, then JavaScript, and C#. The Popularity of Programming Language Index can help you decide which language to study or which one to use in a new software project. The next graph shows the popularity of Python and Java over the years, starting from 2004 till the current period, which is 2020. Worldwide, Python is the most popular language. Python grew the most in the last 5 years by 19.4% and Java lost the most by -7.2%. Now let's talk about the different career opportunities and the job roles that you can get into if you learn Python language. First, you can become a Python developer, where you will be asked to write and test codes, debug programs, and integrate applications with third-party web services. Second, you can become a web developer. Here, you will be responsible for writing server-side web application logic. Python web developers usually develop backend components, connect the application with third-party services, and support the front-end developers by integrating their work with the Python application. You can also become a data analyst if you know Python. As a data analyst, you have to gather data from multiple sources using scripts, analyze that data, develop and implement databases, and data collection systems. You can become a data scientist. As a data scientist, you need to understand the challenges in business and come up with the best solutions using modern tools and techniques to analyze, visualize, and build prediction models to make business decisions. Lastly, you can be a machine learning engineer, where you can develop intelligent machines that can learn from vast volumes of data and apply knowledge without human intervention. So there's a lot of scopes if you learn Python. Now let's have a look at the salaries of some of these job roles. So if you become a Python developer, you can earn an average salary of $76,526 per annum in the United States, while in India, you can earn an average of 4,98,000 rupees per annum. Also, if you learn Python and become a data scientist, you can expect an average salary of $113,000 per year in the United States, while in India, you can earn an average of 10,28,000 rupees per annum. Let me now go ahead and call out the 10 reasons for learning Python once again. At number 10, we had ease of use. At number 9, we had active community. At 8, we had the portable and extensible feature of Python. At number 7, we saw the testing frameworks. At 6, we had libraries and packages. Then at 5, we saw scripting and automation followed by web development. Then we had machine learning and data science at number 3 and number 2 respectively. And finally at number 1, we had career opportunities and salary.
So who is a Python developer? Let's answer this. So here are some of the technologies used by a Python developer. Pandas, Anaconda, TensorFlow, Python IDEs, Django Web Framework, and Python. A Python developer is one who develops backend components of a web application using Python when working as a web developer. Now, the web frameworks like Django and Flask are used for this purpose. A Python developer is also the one who writes effective, testable, and scalable Python code. He also performs data analysis when working in the field of data science. So basically, a Python developer develops, deploys, debugs, and maintains a project. So let's go through the skill set of a Python developer. Now, the core Python skills that a Python developer possesses are data structures like arrays, list, stack, queues, trees, and graphs. There's OOP concepts like inheritance, classes and objects, and abstraction. There's packages and functions, that is importing external packages into a Python code. Database and its connection, that is connecting a Python backend to a database like MySQL. When it comes to data science skills, there's NumPy, that is a library for performing mathematical calculations. There's Pandas, that is the library for storing and manipulating data efficiently. There's SciPy, and then there's Matplotlib, which is a library for plotting charts and graphs for a given data. And finally, there are machine learning algorithms, which consist of models like supervised learning, unsupervised, etc. Now coming to web developer skills, there are frameworks like Django and Flask for backend development of web applications. And then there's web scraping, which includes taking data from websites and converting that data into usable format. There's API handling, which is basically handling API requests for a web application to perform server-side operations. And finally, there is backend connection, which basically involves the backend part of a web application, usually handled by Python frameworks. Now moving on, let's look at the Python developer job roles. First up is Python Web Developer. Now, a Python web developer usually writes server-side code, works on the web frameworks like Django and Flask, collaborates with the data team to gather end users' requirements, develops the server-side platform, deploys applications, performs tuning, usability, improvement, and automation. Moving on, next job role is data analyst. Now, a data analyst generally works on Python libraries including matplotlib, NumPy, pandas, etc., carry out data analysis, collect using the scripting language, explore data sets, gather requirements, tune in applications, analyze problems, communicate findings with the team or stakeholders. The next job role is automation test engineer. Now, an automation test engineer usually works on Python test framework tools including PyTest, PyUnit, perform complex system tests, troubleshoot code issues, create test scripts, design the automation framework, perform A/B testing. Next up is machine learning engineer. Now, a machine learning engineer has the following roles: to perform statistical analysis of data, put machine learning models into production, research and transform data science prototypes, research and implement appropriate ML algorithms and tools, perform ML tests, and keep updated with the ML trends. The last job role is software engineer. Now, a software engineer is expected to write server-side code, collaborate with the design team to gather end users' requirements, develop the server-side platform, deploy applications, perform tuning, usability, improvement, and automation. Moving on to the next topic, let's look at the Python developer salary trends. Now, software engineers with Python skills are offered better salaries across the globe. The average salary of a Python developer in India is around 7,55,000 rupees per annum. The average salary of a Python developer in the US is about $79,000 per annum. Moving on to our last segment, Python developer resume. So let's go ahead and understand what a Python developer resume should portray. Just keep a few things in mind when you're preparing your resume. Your resume should be clear, updated, and concise. You should prioritize the skills according to the job role you're applying for. And do not write anything extra. That's a big no. The recruiters are smart enough to know that. So do not lie and do not write extra. Firstly, let's look at the fresher resume. So if you're a fresher, these are some of the points that you need to know. First, you have the resume header. Now, the summary is supposed to be clear and concise. Just say what exactly you want and some of your strengths. Next is the profile links and your portfolio. So you can mention your LinkedIn profile link and also your GitHub repository link if you have. Next up is the projects. Now, clearly depict the goal of your project. So just in case you worked on, say 5 projects, make sure you keep it concise and crisp. Next up is your education. Do not lie here. Make sure you give relevant education with grades. Next, you have the certifications. If you have any certifications or achievements, go ahead and write them down. Next, you have the technical skills. Now again, prioritize according to the job role. And lastly, you have your non-technical skills. This could be your communication, analytical skills, problem-solving skills, etc. Moving on to an experienced developer. So again, mention the resume header. Then you have the summary, again very crisp and clear. Go ahead and mention your portfolios and your links. Coming to experience, now here you'll have to clearly depict your work. You'll have to make sure that you write down all your responsibilities in that company. Do not go overboard and write extra. Keep it very concise. Again, relevant education and your grades. You have technical skills. The same goes for this as well. Prioritize according to the job role. And finally, you have your non-technical skills.
Now let's go over some of the features of Python. And these features are actually why it's considered that using Python is advantageous over using other languages. So let's start with some of these points. Now, as we mentioned, Python is it's a very readable program. Code readability is very important. It's one of the design philosophies behind this when it was being developed. It's very easy to learn, which is why Python is an entry point for many people that are just beginning to learn programming. And as I mentioned earlier, it's a high-level language. In Python, since Python is open source, as I had already mentioned, so it benefits from all the benefits you get from any open source technology. Now, it's also portable. So what this means is that if we create a code in Python and we create it in a particular system, say on Windows, we don't need to make any changes if we wanted to use the same script or that same piece of code on some other system, say on a Linux system or a Mac system. Python itself comes with a very large standard library. This facilitates us a lot because we don't need to create our own libraries or modules or have to download very specific libraries. Most of the problems that we do encounter quite commonly can already be solved by the standard libraries that have already been provided by the developers of Python right from the beginning. Now, later on during the course, we will encounter what is the meaning of a data structure. A data structure is essentially manipulation of an object of data. And as you will see later, Python has one of the most user-friendly data structures that can be found in any language, especially compared to some of its contemporaries. Now, Python is a dynamically programmed language, and this is very important. And what this means is that in most compiler-based languages, there are certain processes that can only happen during the compilation stage. So what a dynamic programming language does is it takes all those compilation-specific tasks and processes, and it does it for us as we actually type the code. So we don't need to waste time or spend extra time to do something that would otherwise be needed to be only done in compilation. We would have to set out specific runtime just for that. So this allows us to create our programs and solutions much faster and allows us to debug much easier. And so it's a very important feature about Python. Now, quickly, I will just go over some of the areas of Python where, like, areas of or different domains where Python is very heavily implemented. And the first few ones that come to mind are like web development and are AI and machine learning. So you have technologies like Django and Flask that are built on top of Python that are used extensively for web development. When it comes to something like artificial intelligence or machine learning, you have distributions such as Anaconda, you have Pandas, and many other libraries like SciPy and NumPy that are used extensively to tackle problems in this domain. And similarly, Python finds use in most of the scientific work that goes on nowadays because of, again, some of the libraries that I have already mentioned, such as SciPy. Interestingly, if you are into game development or gaming in general, you would see that Python actually has certain libraries and certain technologies that facilitate game development very, very well. One very popular game, if in case you are into gaming, is a World of Tanks that is built on Python. Some of the other applications are, of course, desktop, creating desktop GUIs, image processing, graphic design applications, and something that is very relevant to me and, of course, you as well, is creation of education programs and training courses. There are many technologies in the environment of Python that were almost designed for the specific purpose of being able to present certain concepts or to be able to teach certain classes. And I can't think of too many programs or too many environments outside of Python that are better to solve these education and training course related problems and situations. Let's get to actually installing Python. So now that so I will show you how to install Python on Windows, since I have a Windows system. However, I will also point out the way you would have to install Python on Mac OS or Linux or even on mobile. So let's get started. So to install Python on your Windows computer, it's as simple as going to the website python.org and selecting the downloads section. When you do click on downloads, you get redirected to this website this web page that I'm on out here. By default, it will ask you if you want to download Python 3.9, which is the latest version. But of course, if you, for whatever reason, if you needed a particular version of Python, you can download that as well by just scrolling down and choosing the option that you want. Now, it's important to note that whatever option you choose Of course, I would recommend the latest one, but no matter what option you choose, I would recommend you choose a version of Python 3 point something, because previous versions of Python, namely Python 2.7 and basically every version of Python 2 point something it will not receive any more maintenance and updates because the developers have decided that Python they are trying to shift towards maintaining and updating Python 3 point whatever completely right now. So yeah, let's not delay this any further, and let's just download Python 3.9. So once you select the option out here, you'll get an installer. All you have to do is click on that, and it'll give you two options: to customize installation or install now. I would of course recommend just do install now. Since you're a beginner, do not worry about what a custom installation is. If you have multiple drives in your system, by default the Python will be downloaded into the drive where your Windows is actually installed, your main drive. So as you can see, now that once my setup is done, it should give me a pop-up soon. So my setup is done for Python, and this is essentially how you would download Python on your Windows system. But what if you had Mac OS, or if you were using Linux? Well, for Mac, it's actually almost as simple. You just go, if you see out here below this download button, Python option, you get the website asking you, are you looking for Python on a different OS? And it gives you the options of Linux, Mac, and even other OSs. But for Mac, if you wanted, you would just open this tab, and just like the Windows option, you would choose a version and you would choose an installer for that version. So if I wanted, say, Python, the latest one, I would just download this installer and I would install on my Mac system. Now, when it comes to Linux, I cannot show you exactly how you would install it. There are certain commands that you have to execute, but essentially, again, if you would just choose the Linux option out here, it would take you to a page with different installers and essentially packages for Linux systems in specific. What I would recommend to you, if you are a Linux user and you need Python, is to go over to the realpython.com website, and they have a very good essentially instructions on how to install Python. And since I don't have a Linux system, I cannot directly show you how to install Python on Linux. So yeah, if you do have Linux, please head over to this website, and this should be of a lot of help to you. Now, as I had mentioned, you can actually install Python on your mobile devices as well. So if you were, say, an iOS user, you would go to the iOS App Store and download an app called the Pythonista app for iOS. It essentially is like a full-fledged Python environment where you can develop in Python on your iPhone or even iPad. And if you were an Android user, you would go and download an app called the PyDroid 3. There's a free version and a paid version for this app. And of course, the difference between the free and paid is that the paid supports code analysis and code prediction. These are certain details you don't have to worry about right now. And honestly, if I wouldn't worry too much about installing Python on your mobile devices currently, since I am assuming most people would be learning programming in Python on their PCs or laptops. What I had actually shown you was installing what is called an implementation of Python on your system. An implementation is essentially a program or a software or an environment that allows you to actually work in Python. So what I showed you was how to install the by default or the most basic or reference implementation that has been created by the developers, which is actually called CPython. Even though you would not have seen the letter C or the prefix C, but yeah, that implementation that I had downloaded myself and I had shown you to download is actually the CPython implementation, which is Python built on top of C, the C language essentially. There are other implementations such as IronPython, which uses the .NET framework, and JPython that uses Java virtual machines that you could use if you were interested. But again, these are things that I would not worry about too much right now. So now that we have tackled on how to install your implementation of Python, I want to introduce what is called a distribution to you. This distribution is called Anaconda. Anaconda is a very important distribution, especially if you are looking to use Python in data science and machine learning and AI, which I am assuming is the motivation for many of the people that are actually watching this video, that they actually want to move into data science and they need to learn Python. as a foundation towards moving towards data science. And if that is your goal, or in any case, whatever your goal may be, I would recommend that you install Anaconda distribution. Now, do not get confused between Anaconda and Python. Anaconda is Python with in the form of a bundle, and this bundle contains not only the basic Python implementation that I had shown you to download, but it contains a lot of extra libraries and technologies and softwares as well. So, of course, this means that would you need to download both? Of course not. If you downloaded Python, you do not need Anaconda to work on Python. And if you have already downloaded Anaconda, which I will show you how to do it in some time. If you have already downloaded Anaconda, you don't need to download Python separately. So I'll just speak about Anaconda a little briefly. So as I said, it's a distribution. It contains a bundle which includes the basic Python implementation and a lot of technologies and softwares and applications that essentially help us to use Python in specifically managing big data applications and data science related projects. So now I will show you actually how to install Anaconda on your system. It's as simple. It's actually as simple as downloading just this thing. So if I did a quick Google of Anaconda, so the website that I'm looking for is anaconda.com, and I'm looking at products and I'm looking at individual edition. There are other editions as well, like commercial, team edition. These are for companies usually, or for more professional sort of projects. So of course we are looking at the individual edition, and if you selected this page, you would be taken to this particular web page where it'll ask you if you want to download. And again, there are options depending on which machine you're using. If you're using a Linux, you would choose one of these two. If you are using Mac OS, you would use one of these two. And since I am a Windows user and I have a 64-bit system, this is the option I would use. So again, it will first download an installer for you. And as you can see, my installer has been downloaded. So upon opening it, it will open up this installation thing. You can just click next on most of these. Again, if you want to specify your destination folder, you can change it here. Mine will be with a default folder in the C drive, and you can leave this unticked. You can change these options much later. So this is how you install Anaconda on Windows, and it's pretty much the same on other systems as well. Now once it's done, I will show you what are some of the things that Anaconda contains that are not there if you installed Python, like the way I had shown you earlier, just the bare bones Python implementation. So as you can see here, my installation is actually complete, and now I will open Anaconda and I'll show you how you can actually use this Anaconda. So if I search for Anaconda in my system, I would look for something called Anaconda Navigator to actually get started with this. And when I open that, it should open something like this. So this is what opens when you click on the Anaconda Navigator. And as you can see, there are a bunch of applications. You don't need to worry about what these mean right now. Just understand that this is essentially a bundle of different applications and technologies that come along with just the normal installation of Python that you get when you install Anaconda Navigator. Now that we have actually tackled where we've seen how to install, and I'm hoping, and I would recommend definitely that everyone is watching this video installs Anaconda, not just the normal Python installation or implementation. Now that we have gotten all the introductions and the basics and the installations regarding Python aside, let's get down to actually creating our first script. So now the question is, how do we actually start doing this task of creating our first Python script? How do we realize now that we've installed Python, how do we start doing something? So the answer to that question is that typically when you're working on Python, one of the most basic things that you can do is create a Python script and execute a script. A script is essentially a sequence of commands and instructions that you give for Python to run and execute to give you a certain result. So I will show you how you can create a Python script. Now there are multiple ways of creating a Python script. You can create it directly from command line, which is obviously something I would not recommend because it is not convenient and easy, and it's not very useful for a beginner. Another way is using a text editor, such as the one I have opened right now, which is the Notepad++ text editor, Now, it's very important to not get confused between Notepad++ and the standard Notepad that comes with your Windows or WordPad for that matter. In fact, text editors such as Notepad and WordPad that you are more familiar with create text and files in a form that is called rich text. Now, rich text is text that contains formatting and fonts, which is actually a hindrance when it comes to creating actual code. So what we need is a text editor that creates or writes text in what we call as plain text. Plain text is obviously text which does not contain these fonts and these formattings, and it only respects white spaces and indentations, those two being actually useful towards creating code, unlike fonts and formatting, which are only a visual thing. So Notepad++ is obviously a text editor that creates plain text documents. That was actually created with programming in mind. Obviously, you can use a bunch of other text editors such as Vim and Atom, and you can Google for these. There are plenty of them. So without any further ado, let's create our first Python script. So one of the most common, one of the most famous examples of a first program in any program for that matter, not just Python, is creating a print statement that gives us a statement saying hello world. So in Python, this is how you would go about it, or this is the syntax you would use to create this statement. All right. Now, where it is very important when you are saving your Python program that you use the .py prefix. So if I were to save this, I can choose whatever folder. I am going to choose, this folder seems fine. So now I give the file name over here as, say, I want to keep it as test. I need to prefix this with .py, and this tells any sort of interpreter, or anytime we need to read the script, to know that it's a Python script, we need to add a .py. Otherwise, it will not be treated as a Python script. It will be treated as some normal document sort of a thing. So now that I have stored it as .py, I have created my first Python script. Now, obviously, the next question is I need to see what happens when I execute this line, when I run this script, essentially. So to see that, there are multiple ways. The first way that I will show you is a command line method, which is obviously, again, before we get into it, it's not something that I will be using to teach you. It's not something I would recommend you to immediately start using. But for the sake of showing, I will show you how to execute a script in command line. Well, to do this, you go, since I have installed Anaconda in my system and I will be using Anaconda to work in Python, what I will look for is something called the Anaconda prompt. As you can see, this is the option that I get, Anaconda prompt. This will essentially open you a command line under the environment of Anaconda or Python. So in this, now I am already in the folder, I believe, that had my script. So how do I call this script, or how do I run this script? Well, the command is Python space the name of my file, which was test. Of course, the prefix is very important, so I enter test.py. If this was in a different folder, you would have to change your folders in command line, which is again something that I might show you later. But since my file is already in the folder that I am in my command line, I would just have to enter this command right now. So if I execute this, as you can see, it's given me an output of hello world, which is what I wanted. I wanted it to print this these two words, and of course the command line is now waiting for the next command for me. So this is one of the most simple ways of, or the most rudimentary ways of executing a Python script. Now another question would be, well, this isn't the most visually appealing, or not the easy to read or easy to use way of executing scripts. And I would agree, and that's why I'm going to introduce another technology or a software called the IDE. So the IDE in Python or in any programming language stands for Integrated Development Environment. It's essentially a software that not only allows us to run scripts, but it allows us to create the scripts, it allows us to debug, it allows us to see outputs, it allows us to see intermediary outputs, it allows us to do a wide variety of tools and tasks, and it comes with a bunch of robust features to enhance our Python programming experience. So let's see. So I will show you an IDE called Spider, which comes bundled along with the Anaconda distribution that I had mentioned earlier. So if I open the Anaconda Navigator, as you can see, the Anaconda Navigator shows me a bunch of technologies and options, and I'm looking for something called the Spider IDE, which is over here. As you can see here, it's a scientific Python development environment. This is exactly what I'm looking for. So I am looking to launch this. So now that I've launched it, you can see out here, this is what an IDE looks like. Now this looks very sophisticated, and almost any IDE is a wonderful software where you can create your code, you can debug your code, you can check the results, you can make adjustments, changes, and you can do a wide variety of tasks and functions with relation to your programming. So this is the Spider IDE in particular, and this is how it looks. Don't worry about the exact details. Just know that on this left-hand pane is our current script that is open out here, and out here we will get the results in this is what we call a console essentially. So now that we have already created our script in Notepad++, and I want to open that script and I want to see the result of that script would look in an IDE. So let's just open it so we can browse for our file. And as I had named it test, this is the file over here. I open this, and as you can see out here in the left hand pane, my script has opened, and the command that I had given or had written is out over here. Now if I want to run this application, I press this green button, and as you can see, the result of my execution essentially is over here. It's in slightly small font, but as you can see over here, it says hello world, and the next line is essentially it's waiting for me to do another execution of the script, and then it will give me new results. So let's actually give the system new results. So now that I have printed something called hello world, let's change what's written over here. Let's say I will perform basic maths. All right, and then let's actually perform the basic maths. Again, don't worry about the details, the syntax, what I'm exactly doing. These are things that we will actually cover in upcoming videos and modules. So let's create a variable called a. Let's store a number 3. Let's create a variable b, store a number 5. All right, let's create another variable c, which will store the result of what's in a and b, in the addition of a and b. All right, and let's print the result, or print what's in this variable c, or what's the result of a plus b. I will print a statement saying the result of the addition of 3 and 5 is. All right, and I will put my result over here. As you can see, I should get the result in this pane. So let's execute this, and you can see my first line is executed saying I will perform basic maths, and the next line says the result of the addition of 3 and 5 is 8. So in this script, what I've done is I have performed 2 print statements, and I've performed a basic expression, some variable assignments. All of these things we will be doing later. This is what I'm essentially trying to show you is that IDEs are a very convenient way of not only creating the scripts but actually seeing the results and then making adjustments as well. We can create a completely new script. We don't need to create a script from some special file or text editor. I can just create a new file here, and this is my new script essentially. So I can start working with this new script right over here from the get-go. So IDEs are very powerful. Spider IDE comes bundled with Anaconda. There are other IDEs such as the IDLE IDE. It stands for Indicated Development and Learning Environment. So the IDLE IDE comes as part of the basic Python implementation that I had shown you in the previous video, where if you just installed a basic Python implementation, it would come along with a basic IDE known as IDLE, or Integrated Development and Learning Environment. But of course, since we are using Python, and that is what I would recommend, it comes with a more robust IDE called Spider, which is actually very, very helpful for scientific and numeric applications, and was designed specifically with that in mind. Now, this is not the only way we can actually work with Python. There's another very interesting and a very educative method of creating Python, let's say Python programs. And it's something that I will be using extensively throughout this course to explain different concepts. So this technology is called, or this software is called notebooks. Now, before I get into the details, I will just open a basic notebook. So the notebook that comes as part of Anaconda is called the Jupyter notebook. And when I open or when I launch the Jupyter notebook, this is what I get. Now, a very important feature or a feature of notebooks is that notebooks are a web browser or a web-based application. So it's not something that you can use if you are offline or disconnected. Basically, if you're disconnected from the internet, it is something for which you would need an active internet connection. However, it is way more robust, and it has very, very good properties that allow it to be used in education or for presentations and such. So as you can see, this is my Jupyter notebook. These are a bunch of folders. Don't need to worry about what these are right now. I will show you how to create a fresh notebook. So if you go here, you go to new and you select under notebook the Python 3 option. It will open your first notebook. As you can see, this line is essentially waiting for me to enter some sort of a command or a statement that I would give in a normal Python thing. Now, if you would have noticed until now, everything that we were doing involved us creating a script, which was the whole series of commands and functions. So if I go back to my Spider IDE, as you can see, like this is a whole script, and this script contains multiple different tasks and functions that are individually being performed. So this is a separate print function. This is a separate addition, another separate print function. And for longer programs or larger programs, you have multiple different tasks being done. And if you were using a script, you can only see the result of something like this by executing the whole thing at once. You cannot see exactly what is the result of just this print statement or just this. It's not typically what an IDE is used for. And this is where notebooks come in super handy. If I had to break down my previous script essentially, where I first did a print statement, where I said some random thing, say hello. Yeah. So if I execute this particular line, you can see it gives me the result. Now I want to do what is 5 plus 3. It should give me the result over here, 8. Now the next, another part of your program might be storing 5 and 3 into variables. So I can do this and I can do this. So now this line will store the variables. Now I want to do the addition of what is 5 plus 3, but I want to use the variables. And I want to see what's the result. As you can see, a plus b means 5 plus 3, which is 8. And I've essentially broken down various different parts of my previous script into its individual tasks, and I'm able to see what each part of that script does. And this is very good when it comes to making presentations or trying to teach a class. So I will personally be using notebooks a lot to explain different concepts when it comes to Python. And I would recommend that you get used to notebooks in general, because it's an amazing way to learn Python programming, or programming in general, in fact. And again, as I had mentioned earlier, notebooks are something that it's an online application. It's a web-based application. So I will have to need a active internet connection to be able to work on a notebook, which could be a disadvantage if you do not have a consistent internet connection. And in that case, you would probably use your IDEs or text editors, which can be used offline as well. In this video, we will be introduced to the concept of variables and expressions. Let's start with expressions. Well, an expression in Python is anything that results in a value. Its difference, or the difference between an expression and a standard statement in Python, is that a statement in Python is something that results in an action or an execution of a command. There is no calculation per se, or any sort of manipulation, or, as I said earlier, calculation resulting in between two different, say, numbers or other objects that results in a value. And this happens in the case of an expression. So for example, if I were to add two numbers, say 5 plus 10, this is an expression where two objects, 5 and 10, are being added, and a result is being given to me, which is 15. Now let's see an example of a statement. Well, a statement could be something like a print statement. So when I ask Python to print something for me, it's not calculating anything, it's not evaluating anything. It simply performing an action that I have, or a command that I have given the system, which is to print whatever I have entered over here, as you can see. So this is a statement. Similarly, there are another type of statement known as assignment statements, which we will learn actually right in the next section. Well, let's move on to variables right now. Now, earlier, you might have learned about objects in Python. So objects are essentially data that we can work with or manipulate in Python. Now, variables are a place to store these different objects. Usually, it's much easier to store objects in Python instead of using the objects explicitly themselves, because objects may be very complicated, whereas variables are very simple to use and very simply are named in a very simple manner so that we can use them quite often in our programs. Now, it's important to note that in Python, we do not have to explicitly declare or define a variable to create them. In fact, variables are created in the same statement where we assign some object to that variable. In Python, the assignment of variables happens using the assignment operator, which is the equals to sign. So if I wanted to assign a number, say 100, to a variable, say b, well, it would be as simple as doing this. Now, anytime I want to know what is stored in b, I just have to enter b and I will get the value that is stored in it. And we can store different types of objects inside any variable. Let's say I want to store this particular word in the form of a string. Now this is stored in x, and if I want to know what is in x, I can just see what is here, and it's a string hello, which I had stored earlier. Now it's very important that we follow certain naming rules when it comes to naming our variables in Python, or else we may be thrown errors or we might get some problems in our program. So the first rule is that you cannot start your variable name with a number. So if I were to give a variable name like forNum is equal to something, say the same string hello, this would be an illegal variable name and I will get an error when I try this. So if I were to choose in num4 is equal to hello, this would be perfectly fine. I won't get an error. The second rule is we are not allowed to use any non-alphanumeric characters except the underscore character while naming our variable. So for example, if I were to name my variable num_4 and I said random, some random string, this is perfectly fine. However, if I changed num_4 to num-4, this will throw me an error, as you can see over here. Next, the third rule is that variable names are case sensitive. So if I have a variable called num, or say num, if this was one of my variables and I stored, say, the value 50, this is not the same as me writing num all in capitals and say storing some other value 60. These are two different variables. So it's very important that when you name your variables, you are aware of what case you are writing them in, because Python variables are case sensitive. Now the final and probably one of the most important rules in Python is that you're not allowed to use what we call reserve words in Python. Now Python has a bunch of reserved words. These words essentially are performed, or they are used to perform certain special functions and are used as identifiers for certain special functions in Python that have a special purpose. Like that particular word has a special purpose within the Python programming language, and we cannot use them to name our variables. So a list of them, as you can see over here, some of them are like false, def, if, del, raise, and there are around 33 of them. And sometimes some of these words are taken out. Sometimes there are more words added as Python gets updated. Now let's move on to a concept where we try to really understand what do we mean by storing data inside a variable. Now when I say that we are storing something inside a variable, you get an image or you get an idea in your head that this variable is like a container where we store or we put a particular object inside it. So does this mean that variables have a place in the memory? Are they also an object that is placed in the memory where we can put other objects inside of? Well, I'll show you an example where this idea is kind of disproven, or where I'll show you that the idea of variable is kind of different than what we understand by storing something inside a variable. Now, let's say I'm storing the same object. I will take this object as some random number, let's say 100, and I'm going to store it into two different variables. So I take x is equal to 100 over here, and in the next line I will store 100 in y as well. Now, if if variables were objects that we placed in our system, then x and y should have two different IDs. But let's see what happens when I check the ID of x and the ID of y. They should be different in case variables were their own objects. However, as you can see, the ID of x and the ID of y are exactly the same. So, well, obviously we know that two different objects in Python cannot have the same ID. So what does this mean when it comes to the nature of a variable? Well, the fact is that variables are not actually objects in Python. In fact, variables are more like pointers or references to the actual object. So when I said x is equal to 100 and y is equal to 100, what I'm actually telling the system is that there is this variable name called x that I want to refer or point towards the actual object that is in my memory called 100. And I do the same thing with another variable y. So I am not exactly creating a different space in my system for these variables. These variables are more like placeholders or references that point to a particular place in the memory where this object is located. And that is what happens when I do ID of x and ID of y. It's not giving me the ID of something called x or the ID of something called y. It's giving me the ID of 100 each time because 100 is stored in x and y. So as you can see, this is something like a visual representation of what I'm trying to say. And similarly, if I were to, so in this example on the left, as you can see, I've used the value of 50 to explain my point. So as you can see, initially x and y are pointing towards this value 50 because I have stored 50 and 50 in both x and y. Now what if I changed the object that is stored in x? Well, that means x is now pointing towards this new object, and I have stored this new object called hello, this string called hello, as you can see here. So now x is pointing to a new object in the system and it's called hello, and I haven't changed anything with respect to y, so y will point towards the same thing. And I can also make the pointer of y different, or what I'm trying to say is I can store something else in y. See, I stored this list in y, 50, 60 and 100. And when I do that, now y is pointing towards a different object in Python, and x is also pointing towards something else. So what happens to this object 50? Well, now that there's no variable referring to this object 50, it becomes what we call an orphaned object. And we can actually see that when we do the ID of x, now let's go back to my example on the right where I stored x is equal to 100. So as you can see, it gives me some ID represented by this number. Now let's say I stored something different in x, say 200. Now if I do the ID of x, it should give me a different ID because, as you can see, the values are different. And this is because this object 200 is what is stored in x, and when I do the ID of x, I'm actually getting the ID of this new object now, 200. So as you can see, variables are, they should be, and they are treated more like references or pointers instead of containers for a particular object. In this video, you will be introduced to the concept of objects in Python. Now, what are objects in Python? Well, all the data that we manipulate or use in our operations in our code are represented as objects or relations between objects. So if you want an example, two numbers that you add in your code, well, both of them are objects, and they're usually numeric type objects. Similarly, if you want to store someone's name or an address of your hometown in your code, you usually store it in a form of text, and that text is also an object, usually a string. Similarly, you might want to create a container of different smaller objects inside them, and that big container is also a type of an object, and one of those containers are called lists. And similarly, we have many different types of objects which we will be covering during the duration of this course. The following pictorial representation gives us a broad classification of different Python data types and objects. As we can see, there are 5 broad classifications: numeric, which contains integers, complex numbers, and floats. We have the dictionary data type. We have the Boolean, which essentially consists of objects that have only 2 valid values, true or false. Then we have sets, and we have sequence data types, such as strings, lists, and tuples. Every object in Python has 3 important properties that kind of define that particular object. They are its identity, its type, and its value. The identity of an object is it can be considered as a place in the memory or its address in the memory where an object is stored. An object's identity does not change once it has been created. So for example, if I took an example of, say, a string called hello, I can use the id function, this is how you use the id function to find out the id of this object. And it should be, the answer should be in the form of a particular long integer. So as you can see, the id of hello is this integer 2326476623024. Similarly, all objects in Python have an identity. We have another operation with regarding the identity of an object is the is operator. And the is operator compares the identity of two objects. So if two objects have the same identity, it should give the answer true, otherwise false. Now the next property of objects is the type. The type of an object is essentially what defines what kind of values and operations that object can have. So for example, a numeric data type in Python, such as an integer, would allow us to do arithmetic operations. And similarly, string object type in Python will allow us to do concatenation operations. Much like its identity, the type of an object cannot be changed as well. Now let's see what's the type of that particular object that I had shown you above. As you can see, it should be string. str stands for string. Similarly, if I did a type for a number, say 50, it should give me int, as you can see. Now the third property of an object in Python is its value. Now the value is the actual data that is contained in the object. It's the thing that we use, that we display, that we can manipulate, and that we can perform operations on. So for example, if I were to talk about this string is hello. So the value of the string is the word or the sequence of letters that spell out hello. And similarly, this particular object is a numeric object with the value 50. Let's see, in this pictorial representation, I have shown you that you can assume this dashed blue area as the memory of the system. Now within this memory, we have objects created called 50 and hello, and this list containing smaller objects called cat, pen, and 40. Now, what I'm trying to show you here is each of these objects have a type, an ID, and a value. And let's see what they are. So if I wanted to see, as we had already seen the type of 50, now let's find the ID of 50. As you can see, we get this unique ID for the object 50, which is obviously not the same as the ID of the object hello above. And the value of this object is the variable 50 itself. So that was a brief introduction into objects in Python. In this video, we will cover the topics of numeric object types and type conversions in Python. Well, let's get started. Numeric object types in Python are a broad classification of objects. Plenty of common real-life applications that we associate with numerals, such as arithmetic operations and calculus, are done in Python using numeric object data types. There are three main types of numerals or numeric data types in Python. They are integers, float, and complex. Integers, as the name suggests, represent all integer values in Python. These can be such as 100, -3, to 305, and so on. Floats are used to represent numerals that contain decimal points, such as 100.3, 3.9, 4.8, -6.8, and so on. Then there is the complex object type, which is used to represent complex numbers in Python. And this is an example of a complex number, 3 plus 7j. This is a complex number 3 plus 7j, where the real component is 3 and the imaginary component is 7. All complex numbers have a real and an imaginary component, and this is how we denote them. Now it's important to note that this j is a very common symbol in maths and engineering used to denote the imaginary portion of a complex number. And it's the same in Python as well. So moving on, let's talk about type conversion in Python. Type conversion refers to the conversion of an object from one data type to another, for example from string to an integer. And there are different types of conversions, and let's go through some of them. First of all, let's consider the conversion of something to an integer, and more specifically, let's consider the example where we convert a string to an integer. So let's consider my example string to be something called 145, and I'm storing this within a string for a reason, because I want to convert a string to an integer. So as you can see, I have stored this 145 within my within a variable x, and if I were to confirm that it is actually an integer, I can use the type function and see that it is actually an integer, str. Now let's convert this into an integer using the int function. So how would we use it is simply passing the int, by passing the variable that we want to convert into the int function. And as you can see, this is what I've done over here, but before this I will also store it into another variable. Alright, now let's see what's in y. Well, y gives us 145, but are we sure that it's an int? We can just check it by using the type function. And as you can see, the type gives us the answer int. That means that we've converted the string to an int. Interestingly, we can convert something and also specify what base we have to treat the number as. By default, when we pass something in the int function, the program or Python will treat whatever we have passed within the string as something in base of decimal. But what if we were to pass something that is, well, not in a decimal? Well, we could do it like this. Now let's store y, and in y let's do this, and I will show you what this means. X, and I will give a comma and 8. What this tells Python is, well, I want to convert the string in x into an integer, but I want to treat whatever is in x as a number of base 8. So 145 is actually 145 in the base 8. Now when we see what's in y, we get 101, which is different to 145 because, well, 101 is actually the decimal equivalent of 145 in the base 8. Similarly, if we were to give it in the base 2, we would just replace 8 with 2 over here. Now next, let's talk about converting something to a float. Now as we know, float is just simply something that has a decimal point. So let's convert an integer into a float. How would we do that? Simply by using the float function. So if I gave 120 and I pass this integer through the float function, I should get 120.0. These two are not the same, though they may mean the same things to us, but for Python, 120 is an integer and 120.0 is a different object, which is a float. And this is how we convert something to a float. Now what if we wanted to convert an integer to a string? Well, we can use the str function. We can also use the hex and the oct function if we want to convert a particular number to a hexadecimal or an octal string respectively. Let's look at all three examples. Say I have a number 688 and I want to convert this into a string. I just use the str function around this. So as we know, just to confirm, let's see what the type of 688 is. This should be an int, as we can see. But let's say we convert it into a string 688 and let's store it into some variable. Let's call it a. Alright, now let's see what's in a. It gives us 688 in the form of a string, but we can confirm by checking the type of a. It is an str, so it is a string. Similarly, we can use hex if we wanted to convert an integer into its hexadecimal equivalent as an output of a string. As you can see, this sort of complicated thing is actually telling us that we have converted 688 in terms of hexadecimals. Now, how do we read this output? This 0 should not be treated as anything. It's more like an identifier, which says that the letter after this first 0 is the base of this whole number. So it's saying that X stands for hexadecimal. So it's saying that 2B0 is to be treated as a hexadecimal number. And if you did basic maths, you would find that the decimal equivalent of 2B0 is 688. Similarly, if I did oct, if I use the oct function for 688, it will give me the result something like this. So again, how to read this? The first 0 is to be treated as an identifier and not part of the number. What it's saying is the letter after the first or after this 0 is the base of the number following these two characters. So as you can see, what's this saying is that this whole number is an oct represented by this letter O, and the number itself that we are dealing with is 1260. And 1260 in octal system is the equivalent of 688 in the decimal system. So this is how we've converted an integer into a hexadecimal or an octal string. Now what if we wanted to convert two numeric objects into a complex data object? Well, for that we can use the complex function, as you can see here. If I passed complex 5 and say something like 3.1, let's see what this gives us. As you can see, it gives us a complex object where our real part is 5 and our imaginary part is 3.1. So what this does is essentially you pass two numbers. The first one is the real component and the second is the imaginary component. It combines to give you a complex number, as you can see here. Now let's look at some other type conversions. The next type we will be talking about is converting something to a tuple or a set or a list. So what if I wanted to convert a string into a tuple? I will use the tuple function, and as you can see over here. So let's say I have a string called random. Let's call it random. Alright. Now if I want to convert this to a tuple, I will use the tuple function, as you can see over here. The output will give me tuples where each individual component of this tuple are the individual components or the individual characters of my string random. Similarly, if I wanted to convert the string to a list, I would use the list function. And this will give me a list of the individual characters of the word or the string random. And I could do the same thing with the set function to create a set of individual characters of the string random, as you can see here. So yeah, these were some of the basic Python type conversions that I have shown you. As we learn about more complex data types and different object types in Python, we will learn different type conversions and functions associated with them. In this video, you will be introduced to the concept of strings. Strings are an object type in Python used to store textual data. This textual data could be something like, for example, someone's name. It could be an address of a place, or it could be something like a word or a sentence. Now, strings in Python are an object type that is actually a subtype of a broader classification of objects called sequences. Sequences are objects in Python which contain components placed one after the other, where each component is given what we call an index, a numeric index. This numeric index identifies the component in the sequence and its position within the sequence. Now, since Python is a zero index based language, the first object of any sequence is always index 0. The second is index 1, the third is index 2, and so on. Now let's move on to defining strings. How do we define them? Well, strings are defined using what we call delimiters, and delimiters occur in pairs, an opening and a closing delimiter. In Python, these delimiters are pairs of single or double quotes. So for example, if I were to use single quotes to define a string, I would do it like this. This is a string. As you can see, this is a string is printed over here. This is delimited using single quotes. Similarly, if I were to define a string using double quotes, it's as simple as doing this. This is also a, as you can see. Now a valid question arises. What if I wanted to include a single quote within my string? Well, if I tried to, let's see what happens if I try to print a statement with a single quote naturally inside it. So say I'm saying it's my birthday. Alright, let's see what happens if I try to print this statement. It says invalid syntax, and this is because, as I had mentioned, in Python single quotes and double quotes are delimiters, so they have a special function in Python, and we cannot simply just use them within a string because Python will treat them specially for a special purpose. So what Python will do is it will pair this and this delimiters or single quotes and say, okay, this looks like a string to me, and it's not going to understand the rest of this, and then it will find a random single quote and it won't find its pair, and it will basically throw us an error because of this. So one way or one workaround to introduce single quotes into a string is simply to delimit our string itself using the other type of delimiter or double quotes. So if I want to include a single quote, I will close my string using double quotes. So if I did this instead of what I had done earlier, this is a perfectly valid and legal way of defining my string. And I would do the opposite if I had to introduce, say, double quotes within my string. I would use single quotes to close it. So if I were to write a speech statement, she said, I am hungry. Alright, I want these two double quotes to essentially show that this is a speech, and I'm going to close the string using single quotes. And this is a valid way of doing it. As you can see, my string has these two double quotes. Now, I had mentioned that strings are sequences. Well, let's describe how are they sequences. So first of all sequences in Python are essentially a sequence of smaller objects that form the sequence, right? So let's try to understand like how are strings to be treated as sequences. Some sequences that we will learn later are like lists or tuples. And in all sequences, we can retrieve any particular object or component in that sequence using its index. And how do we use indexes in Python? Well, we enclose a numeric index within square brackets. Now let's see what I'm trying to talk about by this example. Now say I'm storing a particular string called, say, random within. Now my variable name here is test, and I'm storing the string random within it. Alright, and this is a way of retrieving a particular index from test. I write the variable name, and then next to it I put the square brackets. Now I'm supposed to put a numeral within the square brackets to tell Python like what particular index I'm looking for. So let's try 0. Now as I said, Python is 0 index based language. So the 0 index essentially means the first part of, or the first component of a sequence. So let's see what happens when I ask Python to retrieve the first part of what is stored in test. It gives me the string R. In fact, it's just one character R, and it's a string. So as you can see, it has given me the first character of the string random, which is R. So what this shows is that this string random is essentially a collection or a sequence of one character strings. So random is essentially a collection of the string R, the string A, the string N, and so on together combined to form the whole string that we call random. Similarly, if I wanted the character at the third position of this thing, I would use, well, since it's the third position and since we're working in Python, I would use the index 2, and it should give me the letter N. As you can see, it's given me the letter N. So this is how we can show that strings are also sequences in Python. Well, now let's move on to certain string operations and functions that we can perform. Well, as you have seen already, that we can retrieve any particular character within a string using numeric indexes. Well, what if we wanted to know what index is a particular character at? And we can do it like this. We use the index function. So let's say my test, and I want to know where or what position the character D is in my string random. So this is how I would use the index function. Index, and within the index, say I'm looking for the character D, and now it should give me the answer 0, 1, 2. It should give me the answer 3. So if I execute this, it gives me the index 3. So this is the index function that we can use for our strings. Now, what if we want to say slice a string into a smaller part? We want to slice it, and we want to retrieve only that particular slice. Well, here is an example. Say I'm going to use the same string called random, and it's stored in test, right? So the way of doing this is like this. Now let's just see what this does first. As you can see, it's given me A and D, and if I went to my string random, A and D is this particular slice. Now let's try to understand what I have done by entering 1:4. Well, what this has done is it's retrieved a slice from the first position, the first index, which is the character A, up until the fourth position, which is the character O, but it has not included O. So it's very important when I index like this, every time I put something to the right of this colon, I am not including this itself. Alright, so it's essentially when I say 1:4, what I'm telling Python is give me the first, the second, and the third character, but not the fourth one. So it's given me A, N, and D, and this is how we do a slicing operation in Python. Similarly, if I were to say slice from the first, if I wanted only the first and the second character, I would do, this is what I would do. If I wanted the first and the second character, I would do 1, 2, 3. So this way it tells Python that I want the first, I want the second, but not the third of. So as you can see, I get A and N. Now, so this is a basic slicing. What if I wanted the portion of a string from a particular point all the way to the right or all the way to the left? Well, let's consider the example of where I want the portion of the string random from the say 4th character until the left. Well, the way I would do this is test. Now since I want it all the way to the left, I don't enter any index to the left of my colon sign, and since I want everything to the left of the 4th character, I enter 4 here. So as you can see, it gives me A, R, A and D, which is everything from the 4th character of my string random to the left. Similarly, if I wanted something to the right of it, I would just do it like this. I would enter some index here and I would leave the portion to the right of the colon blank. So this will give me everything including the 3rd character, since this is how we treat the indexing in Python, everything including the 3rd character all the way to the right. So this is DOM, as you can see. Now another perfectly valid slicing is, say I want to slice or take out different characters from the string, but I want to skip certain characters. Like I want this one, then I want to skip one, and I want to take the next one, and then I want to skip one. Well, in that case, we have to introduce a step. So one way of doing this is, now how do we read this? So as you can see, I've written 0:6:2. So what this is telling Python is, I want every character from my string test, starting from the 0th character up until the 6th, but not including the 6th, after skipping or taking 2 at a time. Taking 2 at a time can also be assumed as skipping 1 at each step, or skipping 1 character at each step. So what this will do is, it will go to random, it will take the 0th one, it will take R, and then it will skip the next one. So it will not consider A, and then it will pick N, and then it will not consider D, and then it will consider O, up until the 6th character, whichever that may be. And if you see the output, it gives us R and O, which is exactly what we wanted. We wanted R, we wanted N, we wanted O, where we skipped A and D, or we skipped every second character essentially. So this is a way of slicing strings while also skipping certain characters, or skipping characters in steps. Now Python is also there's another interesting technique that we can use in Python to where we can start retrieving characters from the rightmost side of a sequence or a string. We can use negative indexes. So if I were to, for example, show you, let's see what this gives me. Test what is a -1th index. It gives me the character M. Now remember, a string is random, so -1 gave us the last character of the string random, which was M. So this is a way of using negative indexes. And similarly, if I used test -2, it would give me the second last character, which should be the character O, as you can see here. Now there are some other important functions that you may use in Python. So for that, let's create another string. Let's call it upper, lower. Alright, I'm storing it again in the same variable test. Let's see what happens when I use the upper function and what happens when I use the lower function. Now I'm going to use the lower function for this. So these two functions will respectively give us the result, or give us our string in uppercase and lowercase respectively. So as you can see, the upper function created the first string in full uppercase, and the second one created this string in full lowercase. Now another important, and probably one of the most important methods that we use for strings, especially when it comes to data science, is the split function. So let's see what I mean by the split function. Let me create another string. Let's call it hello world. Alright, and I'm going to use a split function, and I'm going to see what happens when I use this function essentially. So what I'm doing in these three lines is, I'm creating the string hello world, I am storing it in test, and then I am using the split function on the test, and whatever result I get, I'm storing another variable called sliced, and then I'm just going to show you what is in sliced. As you can see, what's happened to the string hello world is that I have broken it into its components, or its component words, if that makes any sense, into hello and world, and I've stored both of these into what we call a list. Now you might ask, well, how does Python know that it has to separate at a blank space? Well, the split function by default will break up a string at its blank spaces. But if we wanted, we could break it up using or at every comma. So for example, if I wrote hello world using comma, and if I put a comma inside over here, and now if I try to execute this, like for example, I'm going to look for commas in the string, and then I'm going to try to split it. As you can see, there's no splitting happening. I have one list with my original string itself because it's not found a comma. What if I introduced a comma over here? Now let's see what happens. As you can see, the splitting has happened. It's found this comma and it's caused a split between hello and world. Similarly, in my string, if I put a comma again and I put something else, it should give me the split over there again. So we can define our split using whatever we put in between these circle brackets after the split function. It's just important to note that by default, if in case we do not enter anything over here, it will use blank spaces to do the splitting. Another very important operation and very common operation in strings is what we call concatenation. So if I have two strings first and say another string second, and I want to join these together, well, the operator I would use to do this is called the plus symbol. This is the concatenating operator when it comes to strings. So what is the result of this? Let's see. Let's print this out. Let's print this whole thing and let's see what is the result. As you can see, what this has done is it has combined the string first and the string second into one string called first second. So this is the concatenation operator. Now finally, the last topic in this lesson is the topic of escape sequences. Now escape sequences are special commands that tell Python to either suppress special meaning of some character or symbol in a string, or give some special meaning to an otherwise ordinary character in a string. So let's look at the first example. Now remember earlier in this video where I was telling you like what is the way of writing, or how do we introduce single quotes or double quotes into a string, and I had told you the trick. If I want to use a single quote in my string, I just close it using double quotes, or if I want to use a double quote, I close it using single. Well, another way of doing this is using what we call an escape sequence. And an escape sequence in Python is the backslash character. Alright, so let's see what happens when I use the backslash character where I want to introduce my single quote. So if I use my previous example where I wanted to introduce a single quote and say I'm going to close it using single quotes as well. So I'm going to go back to my error example, so as to speak. Now this would throw me an error, right? As you can see, it has thrown me an error. So what if I used the escape sequence that I mentioned? The escape sequence is just backslash character. Now this is the point of the string where I want my single quote. So I introduce a backslash. Now I have my single quote and I continue writing the rest of my statement. Let's close the string. Now will this work? As you can see, this has worked. So what this has done is this backslash character has told Python to not treat this special character or the single quote, to not treat it specially and let it be as a part of the string. So as you can see, that's what's happened here. Now the next case, or the other use case of escape sequences, is when we want to give a particular character that is otherwise just ordinary some special meaning. So let's take the example of the character T and the character N. We use the character T to introduce tab space, and we use the character N to introduce what we call line break. Well, let's see by an example. So normally the character T has no special function. So the character T within a string will just be outputted as the character T itself. However, as you can see here, I'm going to introduce a backslash before this character T. Let's see what it does. It introduces this thing that we call a tab space, which is a larger than normal space. Similarly, if I were to use the backslash n combination, this would introduce what we call a line break. And if you were to see the output of this, you can see at the point of the string where I have this combination of backslash n, a line break has occurred. So there are plenty of other escape sequences that you may choose to learn, and These are just two of the probably the most common ones that I used. In this video, I will give you an introduction into lists and tuples. Starting off with lists. Lists are a collection of ordered, arbitrary objects that are similar to what we call an array in other programming languages, but lists are way more flexible when it comes to Python. Python lists are a type of sequence, and you might have seen what a sequence is when we were learning about strings. And much like in sequences or any other sequence, list objects are assigned a numerical index, and whenever we want to manipulate an object in a list, we use its respective index. How do we define lists? The lists are defined using square brackets. So this is a simple way or a simple list that I have just created and assigned to a variable a, which contains 3 objects, 1, 2, and 3. Let's talk about some of the features of Python lists. Python lists are ordered, and what this means is that even if 2 lists contain the exact same elements, if the elements are placed in a different order, the 2 lists are actually unique and different. And I can check that over here. I have created a list 1, 2, and 3, and say if I create another list 2 and 1 and 3, the same elements but in different order, I will use the is function to check whether these 2 lists are the same. And if they are the same, when I use the is function, it should give me the value or the answer true. And if they're not the same, it should give me the value false. And as you can see, I get the value false because even though I have 2 lists with the same elements, they are in different orders. And so they are different. And that's what we mean by lists are ordered. The next property for lists are that they can be manipulated using their indexes, or the elements and the objects inside a list can be manipulated using the indexes. And we will see that in the section where I show you list operations. The next property is lists are mutable. What this means is that once we create a list object, we can actually make changes and modify them without having to create a new list object. The next property is that lists are dynamic. And what this means is that as we are making or as we are programming, we can actually make changes to an already created list as we are programming without having to go through a compilation stage. So if we had to say increase or we had to add certain elements to an already created list, that original list grows in size to accommodate for these new elements. The next property is that lists can contain any arbitrary objects. So if I created a list right now where, say, if I want to store some numbers, say some floating point numbers now, and I can put strings as well into my list. All of these are valid when it comes to objects that can be put inside a list. We have no such restrictions, so we can put any arbitrary objects inside our list. The final property that I want to talk about is that lists are they can be nested to any arbitrary depth. What this means is that I can put a list within a list, and I can keep nesting it essentially by putting as many lists I want within my list, and I'm only essentially restricted by my system's memory. So if I created a list like this, within this, say I put another list, and within this list I put another list, I can keep going on doing this, and I'm only restricted by the memory of my system that I'm using. So moving on, let's move on and talk about some important list operations that we will be doing when it comes to lists. So let's create a basic list called A, where I'm storing 6 numbers. So now say if I wanted to retrieve a particular element, say if I wanted to find out what's on the index 3, this is how I would do it. If I wanted a slice of my original list, and much like strings, I do it the same way. So what this does is, it tells Python that I want all the elements of list A from index 1 to index 4, but not including index 4. So it will give me 1, 2, and 3 index objects. So it should give me 2, 3, and 4 in this case. As you can see here, 2, 3, and 4. I can do the same thing by considering elements, say 2 at a time. If I wanted to consider elements or consider every second element, what I would do is this syntax. I would use this syntax. And when I give this command to Python, what it understands is I want every element from A, from index 1 to index 4, but not including index 4. But I am going to consider 2 every second element essentially. So what it will do is it will go here, and then it will skip 1, and then go here, and then skip 1, And that's essentially what we call slicing by using strides. So I'm taking strides. I'm not considering elements consecutively, but I'm skipping certain elements in between. If I wanted to consider every third element, I would change this to 3. And fourth element, I would change this to 4. Alright? So let's see what happens when I take every second element. It should give me, it will consider, say, from 1 to index 3, right? So it should consider essentially this section. But since it's going to skip 1, it's going to consider this, skip this, and then consider this. It should give me 2 and 4. As you can see, it has given me 2 and 4. And like in other sequences, we can use negative indexes as well. Negative indexing essentially starts looking from the right hand side of the list. So when I say a minus 1, it's essentially looking at the last element of the list. So it gives me the sixth or the last element, which is the object 6. If I did a minus 2, it gives me the second last element. Similarly, another neat trick that we can use for sequences is the following syntax: double colon, and we give a minus 1. What this tells the system is I want the list A, but with all the elements reversed. So as you can see, I get my list A, but the elements have been reversed right now. Let's move on to concatenation and replication. Well, concatenation, much like in strings, is done by using the plus sign. So as we know, on either side of the plus sign should be two similar objects. So if I'm doing A plus something, A being a list, on the other side it should be a list as well. So let's add a list like this. Now let's see what's in A. As you can see, my original list has 7, 8, 9 added to it. And I can also add things to the beginning of a list similarly. So if I wanted to add, say, 0, at the beginning of a list, I just do it like this. And I get the element 0 added to it. It's very important to note that I actually added 0 within a list, because if I did 0 like this, it will throw me an error, because like this 0 is just an int object and it's not a list. But when I put the square brackets, I make it a list, and then this concatenation becomes valid because A is also a list. Similarly, if I did A star 2, this is essentially replication, or a replication function, where I'm repeating the values in A twice. If I did A star 3, it's the same function, but now I'll have the elements repeated thrice, as you can see here. Let's move on to modifying list values. This also shows the mutable property of lists that I had mentioned earlier. So let's consider this example. So I created a list with elements where there's the 3 strings: eggs, apples, and carrots, and I have 5 int objects, 1, 2, 3, 4, and 5. Now if I wanted to change, say, the first element, all I have to do is take the 0th index, and say if I want to replace eggs with say mango, this is how I would do it. Now I've replaced eggs with mango. If I check what's in B, you can see the eggs have been replaced with the element mango. Similarly, I can use the slice syntax to replace a particular slice from my list with a slice essentially. So let's look at this. I want to replace the first 3 elements. I want to replace mango, I want to replace apple, and carrot. So what I will do is, I will consider this, since this carrot is the second index, so I will consider 0 to 3 because the third is not counted. Now I'm going to replace this with 3 different, let's see, kiwi and say sponge. Now let's check what's in B. You can see my 3 elements have been replaced. In fact, I don't have to replace like for like. If I want to replace, say, 3 elements with only 1 or 2 elements, that is also possible. So now if I want to replace the first 3 elements, kiwi, orange, and sponge, with just 1 element, this is how I'll do it. Let's say wine. Now let's check what's here. As you can see, 3 elements have been replaced with 1 wine. I can do it vice versa as well. I can replace smaller number of elements with a larger number of elements. But here there is a slight caveat that I want to show you. So an obvious way of doing this would be, say if I wanted to replace the first element wine with 3 different elements, an obvious way would be just consider that element's index and then put whatever objects you want. Say I want to add, instead of wine, I want to add beer, I want to add ball, and say club. Yeah. Well, let's see what happens. Now if I say B, check what's inside my... Well, you can see my elements have been added, but they seem to have been added as is, I had entered a list over here, and that whole list has been replaced, or this wine has been replaced by this whole list in the first position. But that's not exactly what I wanted. I wanted the elements within this list to be individually placed into my list. And the way to do that is not this syntax, but actually what I'm going to show you now. If I want to replace if I want to replace the index or the object at index 0, I would give this statement, a slice statement, where I will give 0:1. So when I do this, and if I, so let's create my old scenario again, where I had wine, and I had 1, 2, 3, 4, and 5. Now if I do this B0, but I give a slice, then this slice is essentially a single object slice. It's essentially the 0th index again. But because of this formatting or this type of syntax that I'm using, what Python will do is, now when I say beer and ball and club, now what Python will do is, it will not consider this whole list and add it to in place of wine or whatever I want to replace. It will actually consider the elements inside of this individually and then replace. So if you see here, now if you see my list, I actually have I've removed wine, and in place of it I've put beer, ball, and club, but these three are actually individual objects within my list and not objects within a list that is then placed within my original list. So this is an important caveat that you should take note of. So moving on, let's talk about certain methods associated to lists. Let's take a simple list now, 1, 2, and 3. The first operation that I want to show you, or the first method, is the append method. So when I do a append, and say if I want to append the list by one object called 4, I just do it like this. Now let's see what's in A. So as you can see, the append has put the object 4 into my original list. Now say if I wanted to append 3 different objects, I want to append 5, 6, and 7 now. Let's see what append function does. Oh no, as you can see, it's done a similar operation to what we have seen earlier when we gave a single index or the single element replacement that we saw earlier. It essentially put this whole list into this particular spot into the list. And this is not what I wanted. I wanted 5, 6, and 7 to be individually placed. And we do have a way of doing that. And the way to do that is the extend function. That is what I'll show you next. Now, if I want to extend, say, the original list by 3 different elements, 8, 9, 10. When I use the extend function, it will not put this whole thing. It will consider each object inside this thing individually and then add it to A. So if you see my result, this is exactly what I wanted. Now, the next method that I want to discuss is the remove method. So the remove method is how you use it is within the parentheses, you put the object that is present in the list that you want removed. So you don't give an index over here, you give the object itself. So if I want the object 8, alright, this number, if I want 8 itself removed, what I will do is put the value 8 here and it will remove it from my list. So if I check my list A, as you can see, the value 8 it's gone. Another similar function to remove is the pop function. Now the pop function by default will remove the rightmost value from the list. But unlike remove, the pop function actually outputs a value and that value is what we have popped out of the list. So by default, it will pop out the rightmost value of a list or rightmost element of a list. And in this case, that element is 10. So it should give me 10. But of course, if we want to pop out any particular object, in this case, we do not give that particular object, we give its index. So now say if I want to remove this list object from my bigger list, as I can see, it's in index 0, 1, 2, 3, 4th. It's the 4th index. So if I want to remove the list which is at the 4th index, I give the index value inside the parenthesis and it pops that out for me, as you can see over here. So this was it for lists. Let's move on to tuples next. So tuples are another ordered collection of objects much like lists, but they differ from lists in 2 key properties. First of all, tuples are defined using parentheses instead of square brackets. So this is how I would define a tuple with elements 1, 2, and 3. And the next very important property that is different or that differentiates tuples from lists is that tuples are immutable. And what this means is that once we create an object of type tuple, we cannot make any modifications to it. We would have to only create a new object if we wanted something different. And this is obviously a key difference between a tuple and a list. But apart from this, every operation that we have done on lists are actually possible to do in the case of tuples as well. So any operation that we did to lists that did not modify the list, or that does not do any modification, we can actually apply to tuples as well. So if I wanted the first element of this tuple, all I have to do is call it by the index 0. It should give me the value 1, as you can see. If I wanted a slice, I can do that as well. It should give me 2 and 3. And if I wanted to reverse my tuple, well, I can use my same neat technique that I've used for lists and that I can use for strings as well. So it gives me my old tuple, but with the elements reversed. So now the natural question is, why do we use tuples over lists? Well, one important difference is that when we make a program execution where we are manipulating a tuple, if we did the same thing for the exact same objects in that if it were present in a list, it would be much faster in a tuple. Essentially, program execution is just faster on tuples when compared to an identical list. So you use tuples over lists when we want to be efficient while we are creating an ordered list of objects. So whenever we create an ordered list of objects that we don't need to, or we don't want to make any further modifications to, we don't need to create a list, we can create a tuple. And another very important area where we use tuples over lists, or why we need a tuple instead of a list, is when we are using dictionaries. Dictionaries, as we will see later, is a data type in Python that needs an immutable component while we are creating the dictionary. So if we want to use something that is like a list, but since lists are mutable, we can use a tuple instead and use that when we are creating our dictionary. And we will see like what I mean by the immutable component for a dictionary when we actually learn about dictionaries. But yeah, these are some of the places where we would use a tuple over a list. A brief section on tuple unpacking and packing is what I will be doing right now. And what that means is that when I give this sort of a statement, you can assume this to be me packing this tuple into a object or a variable t. Now what's very interesting is, and this is something that's very key to tuples, is that I can unpack a tuple onto another tuple. So let me show you what I mean by that. So now that I have packed 1, 2, 3 and 4 tuple into t, let's unpack it into another tuple. Let's call this, let's put these elements into this tuple, and I put this into t. Alright, now let's see what I mean by unpacking something onto something. Let's see what happens when I put a. If I just want to see what's in a, it actually gives me the value 1. If I see what's in b, it gives me the value 2. If I see what's in 3, it gives me value 3, and d gives me value 4. So essentially, if you think of it, what I have done is I have matched this tuple, then put it into t, and then put that tuple t into this tuple a, b, and c, d. So what has happened essentially is the element a has been, or a better way to say this would be the element 1 has been packed onto or unpacked onto a, 2 has been unpacked onto b, 3 has been unpacked onto c, 4 has been unpacked onto d. To show you what I've done in a single line is essentially this. This is essentially what I've done. I have assigned 1 to a, 2 to b, 3 to c, 4 to d. I have matched these two tuples together like this, and this is a very neat feature of tuples. The only important thing that you have to keep in mind is the elements on this tuple and the elements on this tuple should be equal. So if there are 4 elements here, there should be 4 elements here. Alright? In fact, another very important thing about, or a neat feature, is that we don't really need to mention the parentheses when we're doing this unpacking or packing. So if I did x, comma y, comma z, if I did it like this, if I put say 5 and 6 and 7, this is also a valid way of packing and unpacking. So now if I see what's the value in x, it is actually 5. If I see what's the value in y, it is 6. If I see what is the value of x and z, it should give me a tuple containing 5 and 7, as you can see over here. So this is a neat feature of tuples called packing and unpacking. In this video, we will cover concepts surrounding dictionaries. Dictionaries are another type of composite data type in Python that are also a collection of objects, much like tuples and lists. And like lists, they are also mutable, dynamic, and can be nested. However, a key difference and property of dictionaries is that they are unordered. Items in dictionaries are paired using keys, unlike in lists and tuples where the objects are assigned numerical indexes. To define a dictionary, we use curly braces. Each key value pair in this dictionary in a dictionary is separated using commas, and the key and values themselves in a pair are separated using a colon. Let's look at an example. This is a dictionary where I have 3 key value pairs. As you can see, they have been separated by colons, and each pair themselves are separated by commas, and these are enclosed in curly braces to define the whole dictionary. In this example, these are the keys: banana, apple, and grape, and their respective values are yellow, red, and green. So this is very important, that in this particular data type, we have what we call a key, and that key is assigned a value, and we can have multiple such pairings, and we have 3 such pairs in this particular example. Another example, or another type of way to define a dictionary is using the dict function. This is how we use it. As you can see, I have inputted 2 value or 2 object tuples. This is a tuple, this is a tuple, and this is a tuple. And when I use it in a dict function, when I place it within a list, what Python will do is it will consider the first element of each tuple as a key and the second element of each tuple as its respective value. Now if I check what's in D, as you can see, the key banana has a value yellow, the key apple has a value red, the key grape has a value green. So this is another way of defining dictionaries. An important note over here is that the objects that we use for keys have to be of an immutable data type. So we cannot use, for example, lists as an example of keys, but we can use, say, integers or strings for our dictionary keys. Also, keys have to be unique when it comes to a dictionary. You cannot have 2 different keys with, or should I say, the same key having 2 different values. You can have only one key, and that one key will have a unique value assigned to it. Duplicate keys are not allowed. However, when we speak about values, we have no such restrictions. You can have a mutable or an immutable data type as a value in a dictionary, and you can have duplicates as well. So, if I created a dictionary with a key, say, banana, and if I associated with it a value green, I cannot create another key banana and associate a value yellow. Let's see what happens when I actually do this. If you actually see, what has happened here is Python has considered the second case. So it first looks at the first pair and goes, okay, so my dictionary has a key banana with a value green. But right after it, it sees another key banana with a value yellow. So it overwrites my first key banana with the second key, and it overwrites the first value green with the second value. And we essentially get one key banana with the second value yellow. So obviously, this is Python does this to avoid duplicacies. However, if I created a dictionary with a key banana again, if I gave it a value yellow or say green, if I created another key, and if I gave this also a value green, this is perfectly fine, and this will nothing special will happen in this case because values do not have to follow such rules. Let's see certain dictionary operations and functions now. So let's bring back our original dictionary, which we had created earlier with the 3 pairs. Alright. So what if I wanted to, we can use keys to essentially do these operations and functions. Let's see what happens when so much like how we use indexes in example of sequences, we use keys when it comes to dictionary. So let's see what happens when we use a key over here. So as we know, banana is a key in this dictionary. Let's see what happens when we give this command. It actually gives the value associated with that key, which is yellow. what if we wanted to change a particular value associated to a particular key? I would do this. I would give the key and assign it the value that I want to change it with. Alright. Now if I check my dictionary, you can see the key banana no more has yellow value but the value gold. What if I wanted to add a new pair? You know, a new key with a new value completely. I would do it pretty much the same way as I did in the previous step. I would essentially write my new key, whatever I wanted. Say if I wanted a new key called watermelon, I would assign it a value red. And now if I check my dictionary, at the end of the dictionary, you will see that my new key value pair has been added, watermelon red, as you can see over here. Now what if I wanted to remove a key value pair from my dictionary? I can use the delete function, which is called by using this, the del function. Now how do I do it? Say if I want to remove the key value apple and red. So all I have to do is do del, d, and within square brackets, I have to only mention the key. I don't even need to mention the value, just the key. So you can probably draw parallels in how we use indexes when it comes to lists and tuples and even strings, and how we use keys when it comes to dictionaries. They are quite similar. So if I did this, and if I, I think red is actually not a key. As you can see, red is a value. My key is apple actually. It's not red, it's apple, as you can see. Now if I see my dictionary, the key apple and its value red has been removed. So these are some of the operations that we can do for dictionaries using keys. What if we wanted to use certain inbuilt functions that are associated with dictionaries? Well, some of the examples are as follows. There is a get function. When we use the get function, all we have to do is enter a key inside the parenthesis, and it will get the value associated with that key. So if I gave the key grape, let's see what value is associated with it. As you can see, it's green. There is also a function called items that returns the key and value pairs in our dictionary as a list of two object tuples, where the first object is the key and the second object is a tuple. So let's see what it does. As you can see, it gave me a list, and in this list the objects inside the list are two object tuples, where the first object is always the key and the second is the value, and it's the same for each of the tuples. So this is what items function does. Let's see what the next function is keys. Let's see what the keys function does. As you can see, it returns a list of all the unique keys within our list, within our dictionary. Similarly, there is a function for values as well, and as you can see, it returns all of the different values that are present in our dictionary in the form of a list. Also, it's important to note that if we have a particular value that has occurred multiple times in a dictionary, it will appear as many times it has occurred in the dictionary or appeared in the dictionary in our list over here when we use the value function. So if, say, a particular value, say I had another key where its value was green again, so I would have the value green appear in this list once more, essentially. Our next function is pop item. What this does is, much like the pop function in lists, it gives us the last entered key value pair that is present in our dictionary. So the last entered pair was watermelon, key watermelon with the value red, and that's what has popped out when we give this function. Another important function associated with dictionaries is the update function. And the update function is a very neat function that is used to merge two dictionaries together. So say if I had a dictionary, let's say I'm creating a dictionary using the dict function where I have, say, some key called kiwi. So as I had mentioned, I will use two object tuples in this case, and let's say I give this also a value green. All right, and another pair would be, say, mango, and let's give it a value yellow. All right, so this is another dictionary that we have created, as you can see over here, We have created a dictionary with a key called kiwi with value green and another key mango with a value yellow. And I already have a dictionary D with these values. Alright. Now if I want to merge these two dictionaries, I can use the update function. What I do is say if I want to merge D with X or X with D, only the ordering will change, and that doesn't really matter when it comes to dictionaries. So if I want to merge D with X, I use D update, and then inside it I put my target dictionary. Now when I check what's in D, I have the dictionary X and its key value pairs merged inside my original dictionary D. As you can see, I have my original ones here and I have the merged ones over here. So this was the update function. In this brief video, I will explain what we call the type hierarchy or the standard type hierarchy in Python. It's also known as the data model in Python, and it probably has other names. So essentially what we do or what we speak about in this is how the different types that we use in Python are categorized and classified and what are their subtypes. So it's important to note before we continue further that in future versions of Python, there might be new types that are introduced or the existing ones may be modified. But it's safe to say that what I will speak about in this video will still form the core of what we call Python standard type hierarchy. So let's begin. So the first type is the none type. It's accessed through the built-in name none. Its truth value is false. It's essentially used to denote functions, or it's returned as the value for functions that don't really return anything. So if you have an expression or a function that returns no particular value, you actually get a data type called none. That is how Python interprets it. Then there is the ellipses. Ellipses is something that you might encounter later. It is accessed through the built-in name ellipses. It is used to indicate the presence of this particular syntax, this particular symbol or expression or syntax in a slice. Its truth value is true. Again, don't worry too much about ellipses right now. Next is numbers. And numbers is something that we are very familiar with. We've worked with numbers a lot. They are an immutable type. They are created through numeric literals, and they are the outputs of arithmetic expressions and built-in arithmetic functions. Its subtypes are integers, floating point numbers, and complex numbers. Within integers, you have plain integers that represent numbers in the range this number and this number. So this number is basically the largest positive value that you can represent using 32-bit notation in 2's complement, and this is the equivalent for the negative side. Long integers, on the other hand, are used to represent numbers in an unlimited range that is only subject to the available memory of your system. So these are two types of integers, and as we know, floating point numbers represent machine level double precision floating point numbers, or numbers with a decimal point and a component after that. Complex numbers are numbers that contain a floating point number that represents a real part and a floating point number that represents an imaginary part. So these are the types of numbers. Then we have sequences. Sequences are finite ordered sets indexed by natural numbers. So each element in a sequence has an index, and that index is a natural number. The different types of sequences are based on the mutability, whether the objects can be changed or not is essentially what we mean by mutability, right? Once we create an object, whether we can modify it or not. That is how we differentiate different types of sequences. So there are mutable and there are immutable types. The different types of immutable ones are strings. We know what strings are. They are sequences that contain characters. Unicode is the other immutable sequence, and then there are tuples. Tuples are a collection of arbitrary Python objects, and unicodes are sequences that contain Unicode characters. Then we have mutable sequences, and there is only one. Currently, there is only one built-in mutable sequence in Python, and that is lists. Lists are also, again, collection of arbitrary Python objects. Finally, we have, well, not finally, but next we have mappings, and mappings are, again, sets of objects, but these objects are now indexed using arbitrary index sets. You know, the difference between a mapping and a sequence, you could consider sequences are ordered, but mappings are not ordered, and the indexes given to the objects in sequences are always numbers. They're natural numbers, whereas in mappings they are not natural numbers, but they are certain arbitrary objects that we can set for ourselves. Again, in Python there is only one built-in standard mapping type, that is the dictionary. Dictionaries are they represent finite sets of objects indexed by nearly arbitrary values. The only condition is that these indexes must be of an immutable data type. So what I have mentioned until now are probably the most common data types that we encounter or that we have encountered now. So next types are like callable types, such as user-defined functions, user-defined methods, built-in functions, built-in methods, classes, and class instances. So again, callable types as a whole are referenced using the call function, and this is something that we will learn when we start learning about functions, when we learn about object-oriented programming and methods and functions and such. The other type are modules. So modules are module objects, or modules essentially are referenced or called using the import function. Again, modules can be considered as these large libraries or larger pieces of code or applications that that contain various different methods and functions and objects and classes within them. Again, modules are something that we will think about a little later. Files are data types that are called using the open function. So anytime and as we will during the course of this tutorial, during the course of this course essentially, we will be working with a lot of files. Some of these files are text files, some of them are comma separated files. So all of these files that we open using the function open or some other certain specific functions where we create file objects out of these files. These are what we call file data types. Finally, there are internal types that are used by Python interpreter. Again, this is something that does not concern us right now, but just know that the interpreter for Python uses these data types for its functioning. In this video, I will show you some of the categories of operations that are possible in Python. So let's start off. So the first category of operations are arithmetic operations. And as you can see in this table, there are different types such as addition, subtraction, multiplication. So let's go over them one by one. So a simple addition operation would be like 5 plus 6, giving me the value 11. I can do 5 minus 3, that's subtraction. Similarly, I can do a multiplication using 5, say 5 into 2. There's division where I use the backslash. So say I did division of 8 divided by 2. Now you might encounter another type of division which is called the floor division, where we use a double backslash. And what this does is it returns us the largest whole number that is lesser than the result of our division. So the difference between the float division and the normal floored and the floor division, or the single and the double backslash, is this. Say I did 9 divided by 2 using a single backslash. It should give me, as you can see, 4.5, right? So this is the actual value. Now let's see what happens when I do 9 double backslash 2. It will give me 4, which is the largest number lesser than or equal to 4.5. That is also a whole number. So this is what we call floor division essentially. Finally, we also have, if we want to raise something to the power or something. So if I want to do say 6 raised to the power 3, so I would use double asterisk, and this is how I would do it. It will give me 216, as you can see. If I wanted remainder between the division between two different numbers, I will use the percentage sign. So if I wanted the remainder of the division between 7 and 3, this is how I would do it. I get the answer 1, as you can see. So the next category of operations are logical operations. The first one is the logical AND operation, where we use the operator AND. Alright, so let's see what we mean by this. So as we know, the AND operation returns the value true if both the operands are true. So let's actually do this for an example. Let's give this variable the value true and this the value false. Actually, it should be done like this, true and false. So now think of it like 1 and 0. So 1 and 0 is obviously 0, right? So if I did A and B, I should get the answer false or 0, because I'm doing true and false. So it's like doing 1 and 0. So if you see this, I should get the answer false. If I change this to true as well, now if I do this, I will get the answer true, as you can see. The next logical operation is the OR operation, where, logical OR is if either of the operands are true, then we should get the answer to our OR operation as true as well. So in this case, obviously, if I did OR over here, it will naturally give us true. If I change this to false, it should again give us true, and it will only give us false if both are false, as you can see here. Now it's false. The next operation is the logical NOT. It's done by using the NOT operator. So in this case, the value that we get is true if the operand is false. So let's take A. As we know, A is false over here. So if I did not A, I should get the answer true. But if I change this to true, now if I do not A, I should get false, as you can see. So this was the logical operations. Let's move on to the next set of operations, that is comparison operations. So there are a bunch of them. Let's go over them one by one. If I want to check if two operands are equal, so if I did x is say equal to 2 and now y is equal to 3. If I want to check if they are equal, I will use the double equals to sign. And if they are equal, I will get the value true. If they aren't, I'll get value false, as you can see, since x is 2 and y is 3. As you can see, x and y are not the same, so there's false. They are not equal. If I change this also to 2, now I will get the answer 2. The next comparison is the not equal to, or where we use the exclamation sign. So over here, the result of this is true if x and y are not actually the same. So I should get false over here, as you can see. But if I change this to say 5, now I will get true because x is not equal to y in this case. The next one is greater than. So if I did x greater than y, as we can see 2 is not greater than 5, I will get false over here. Similarly, there's a lesser than. If I did x lesser than y, I should get true over here, as you can see. There's also a greater than or equal to and lesser than or equal to. We simply add the equal to sign here. So let's see. Now if I say x is lesser than or equal to 3, I should get true because x is 2. And if I put 2 here, I should also get true. But what if I put 1 here? Since x is equal to 2 and 2 is not lesser than or equal to 1, this is a false statement. And I can do the same thing with like this, using the greater than equal to. Now it's true because 2 is actually greater than equal to 1. And so this was comparison operations. The next set of operations that we can do in Python are assignment operations. We've already seen a whole bunch. We've already been assigning values to variables. We've been doing assignments throughout already, but let's go over them and see some of the assignment operations. So as we already know, the equal to operation is assigning everything that is on the value on the right hand side of the equal to sign to what is on the left. So if I did a is equal to 5 plus 6, it will assign the value 5 plus 6 or 11 to a. Let's check what's in a. As you can see, it is 11. There is a plus equal to sign, and what this does is, so for example, if I did say a, now since a is 11, let's create another variable called b and call this 5. Alright. So now if I did a plus equal to b, what this will do is it will add b to a and then store it in a. So let's see what this does. Once I do this, now let's check what's in a. It should be 5 plus 11. As you can see, 16. So this a plus, so this plus equal to sign is essentially the same as doing a is equal to a plus b. It's essentially the same thing. They're both the same. There's a similar thing for this, the negative or subtraction as well. Minus equal to. So now that a is 16 and b is still 5, of course, if I did minus equal to b, now I'm subtracting the value 5 from 16. So I should get a is equal to 11 again, as you can see here. And this is the equivalent of doing a minus b. A is equal to a minus b, I mean, as you can see. So the next similar like assignment operation, let's create a is equal to say 6 in this case, and say b is equal to, I will say 2. Alright. Now if I do a star equal to b, what this does is it multiplies b to a and then assigns it back to a. So if I see what's in a now, it should be 12, as you can see here. Similarly, there is similar thing for subtraction as well. So if I did a is equal to 6 and b is equal to 2, if I did for division. So if I did a division symbol and the equal to sign, and then if I give b, what it will do is it will divide a by b or 6 by 2, and it will assign that back to A. So my value in A should be 3. As you can see here, 3.0. Obviously, this is a single backslash, so this is a float division. The resultant of a single backslash is always a float. I can do the same thing with a double backslash. So let's see if I did A is equal to 7 now, and then B is equal to 3. Now, if I did a double backslash equal to B, now it will do the same division, but it will do a float function. So it should give me 2 in this case. If I did the same thing with a single backslash, just to show you the difference between single backslash and double backslash division, in this case it will give me the value around 2.3 or something, a float basically, 2.33 as you can see here. Then there is the modulus. You can use the modulus sign as well with this assignment. Say A is equal to say 5 now, B is equal to 2. Now if I do a percentage symbol equal to 2, B, it should give me, it will assign the, it will take the modulus in both sides and then assign it to the left hand operand. Now let's see what's in A. As you can see, it did A divided by 2. The modulus symbol is basically the remainder of the division between two objects. So in this case, it will divide A by B and then give me the remainder and then put that remainder back in A. And as you can see that the remainder of 5 divided by 2 is 1, and we get that over here. Similarly, we can also do exponential. So if I have A is equal to say 5, B is equal to 2, and I want to raise A by, if I want to raise the value of A by the value of B and then store that back in A, this is how I would do it. So it should be 5 to the power 2, which is 25, as you can see here. So this is assignment operations. So finally, we move on to two special sets of operators. One is the identity set, identity operators, and the other is the membership operators. Let's look at the identity operators. So when we talk about identity operators, what we mean is the is and the is not operator. So what the is operator does is it checks whether two operands have the same location in the memory essentially. This does not mean that it does not check for whether two objects have the same value, and this is very important. So let's look at this. If A is equal to 1001 and B is equal to 1000 plus 1, alright? If I did A is equal to 2, this is an equality check. Are they the same values? True. Now if I say A is B, let's see what happens. As you can see, it's false. This is because this object and this object are not the same, and this is what the is operation does. We can confirm this by checking the ID of A. The ID of A gives us some value like this, and the ID of B gives us, as you can see, a different value. So the two objects are not located in the same place in the memory, as we have seen using the ID function, and that is what we check through the is operator. And the is not is essentially just the opposite of that. So that is the identity operator. Now the membership operator is used for checking whether something is present in a sequence or not. So let's create a sequence. I will create a list to show in this example. My list is 1, 2, and 3. Basically simple list with 3 integer objects, 1, 2, and 3. I will check whether now say 2 in A. So is 2 in A? If it is, it will give me true, as you can see. Is 5 in A? It should give me false because 5 is not in A. And the not in operator is just the opposite of that. It checks the other condition essentially. So this is the membership operators in Python. In this video, we will be looking at the math module in Python, and we will look at some of the math functions that are associated with this module in Python. So starting off, what is this math module? Well, the Python math module is an important library or a feature that is designed to deal with mathematical operations. This math module is part of the basic Python installation, so you don't have to install this separately. To use this math module, all you have to do is import this module, and this is how you would do it. You just do import math, and this will import your math module for you to use in your programming. And in the course of this video, I will be showing you certain concepts surrounding the math module, such as what are the constants that come with the math module, some of the arithmetic functions, the logarithmetic functions, power functions, and even trigonometric functions that we can do using this math module and the functions inside the math module. So starting off, let's look at some of the constants that are part of this. So as you can see, the standard constants that are available in this module are pi, there is tau, there is Euler's number, NaN, which is a special, it's a programming specific concept, and infinity. So let's look at these one by one. So starting off, our first constant is pi. Pi is, as you know in maths, it's the ratio of a circle's circumference to its diameter, and pi is an irrational number. You know the value of pi is 3.14 something. Since it's an irrational number, we cannot define it in terms of a specific fraction, but it can be approximated to the fraction 22/7. So how do we access this pi constant? Is as simple as this. Once you have imported maths, the maths module, all you have to do is do maths.py, and it will give you the value, as you can see. So as you can see, the value returned to us is a float. This is important to note. And the number of decimal digits, the number of digits after the decimal point that we can see here are 15. And this is like a by default thing for Python, that if you call the pi constant, it will give you the value of pi correct up to 15 decimal points. So an example of where we can use this thing is, say we have the radius of a circle 3. It can be in any units, 3 meters or whatever you want, and you want to find out its say circumference. So as we know, the circumference of a circle is 2 pi r. So if I had to find the circumference of a circle in my code for some application with the radius 3, all I would have to do is use the formula 2 pi r, and to call the value 2 pi r, instead of specifically writing 3.14 something, I can just use this function math.py over here, and then I can enter the r. As you can see, it will return me the radius, as you can see. So moving on, the next constant that we will talk about is tau. Tau is similar to pi. In fact, tau is the ratio of a circle's circumference to its radius. Pi is the ratio of a circle's circumference to its diameter, and tau is the ratio of a circle's circumference to its radius. It's important to note this difference. So because of this definition, tau is always 2 times the value of pi. This is by definition. And much like pi, if you call the tau constant from the math module, it will also return you a float number. And to find that, this is the function that we use, or this is the syntax. So as you can see, this is actually 2 times the value of pi, 6.283, and even this is returned correct up to 15 places to the right of the decimal point, and this is by default. Next constant is the Euler's number. The Euler's number is it's one of the most widespread constants used in the world of in the scientific community, in the mathematical community. You will be using the Euler's number probably a lot as if you move into data science or AI or something like that. So what is the Euler's number? It is the base of the natural logarithm. If you know what the natural logarithm is, it is used to calculate rates of growth or rates of decay. And as with numbers or constants like pi and tau, even the Euler's number is an irrational number with infinite decimal places. The value of the Euler's number, in short, it's denoted by the small letter e. So this value of e is usually approximated to around 2.718. So how do we call this constant? Is simply as math.e. This is how we do it. So you get this value. Again, this is also a float, and it's correct up to 15 decimal places. So the next concept that we will be talking about is infinity. Now infinity it's more of a mathematical concept, and this is very important to note because infinity is not really a number. There is no number called infinity. It is used to define something that is infinitely large or infinitely small. So positive infinity is something that is higher than any known number to us, and negative infinity is lower than any known number to us. So this is the concept of infinity. And how do we call this function? Well, let's see what happens when we call the math function, math constant infinity. So this is how we do it. And as you can see, it will return us this, it might look like a string to you, but this is actually a special type in Python, which is not a string. This is also a float. It's a type of a float. In fact, this infinity value, it's like a special data type. It's a special data type that you can consider as an equivalent to a float, but it's not a typical float that we know, like 3.14 or 2.71. The value of math.inf will give us INF, and this INF is actually not a string, so we can confirm that over here. As you can see, when I check the type, you see it's actually a float. In fact, this was recently added in Python 3.5, a special type known as math.inf. It returns this inf data type, which is the equivalent to a float. So this is how we use infinity. If you wanted to get the value of, say, minus infinity, all you would have to do is math.inf with a minus sign preceding this constant, and you will get minus inf. Now let's check if the concepts or the properties of infinity are maintained. Like a positive infinity is greater than any number that we know, and negative infinity is greater than any number that we know. So let's just confirm this. So I will take math.inf and I will do a check. Is this greater than, say, some really large number? Something that comes off the top of my head immediately. Okay. So let's see if this is true, then this is conceptually correct. And as you can see, it is true. In fact, I can change this number to anything as large as I want. This will be true because infinity is larger than any number that we know. And similarly, if I did minus math.inf and I checked some very small number, a very, very small negative number. So just consider some minus 10 to the power something, right? This should also be true. Sorry. It should be smaller sign symbol. This should also be true because I'm checking minus infinity. It's smaller than any known number to us, and it is true, as you can see. So it's very also if you did something like, so let's say if we do let's add something to this. It's a number, so we should be able to do arithmetic on this. Let's actually see what happens when I add, say, 10 to positive infinity. It actually gives us the same value back, infinity, because intuitively we know that infinity plus anything is still going to be infinity, right? And this is exactly what Python does for us. Even if we add a number to this math.inf or the infinity constant in Python, it will still give us the same value, the same data type of inf or infinity. Similarly, if we subtracted something from the negative of math.inf, let's say minus 100. So if we subtract something from minus infinity, we're technically still minus infinity itself. So this will again give us minus inf, as you can see, and this is absolutely what we need, and this is a very, very interesting feature in Python. Finally, the last constant that we will discuss is the NaN, or the not a number constant. So this is not really a mathematical constant. There is no constant in maths called not a number. This is a computer science related concept that it's used to denote invalid inputs, or it's used to indicate certain places where, say, a variable that should have a number it's been corrupted for whatever reason, and it now has a text or a symbol, and our code throws an error. Then in these cases where Python expects a number from us or from your code and it does not get it, it will throw you a NaN value, and this is usually used in cases where you have errors in your code. So again, just to check like what this constant, how to call it, this is how you actually do it, math.nan, and it will give you a data type called nan. Also, much like the infinity constant, let's see what's the type of this constant. Again, it might look like a string to you, but of course this is not a string. This is a numerical concept, and as you can see, it's still a float. So this is like it's another special data type that was created for specifically this case, where it's the equivalent of a float, but it's not really the typical float that we associate with. So this was constants in the math module. So our next topic will be arithmetic functions that we can do in the using the math module. So some of the common arithmetic functions that are available to us are factorials, the ceiling operation, floor operation, there's permutations, there's combinations. You can find the greatest common divisor, or the GCD, and the LCM, or the least common multiple, and you can truncate numbers. So let's look at them one by one. So starting off with the factorial operation. The factorial operation is done using the factorial function, as you can see here. Actually, it's defined like this, math.factorial. Alright, so now what we pass in between the parentheses will be what we calculate the factorial for. As you know, factorial is always for a positive integer, and the factorial for, say, a number 10 would mean 10 times 9 times 8 times 7, so on until the number 1. Obviously, factorial is only defined for positive integers. It is not defined for negative values or It's and it's also not defined for decimal values. So let's look at an example. So as we know, so let's say we pass maths.factorial for 6, and let's see what's the value. So this is exactly what we expect. So we expect the value of 6 times 5 times 4 times 3 times 2. That is actually 720. Let's see what happens when we pass 0. This should give us 1, since we know 0 factorial is 1. Now let's see an error case where we pass, say, minus 5. As you can see, this will throw us an error because factorials are not defined for negative numbers. Now moving on, so the next function that we'll talk about is the ceiling function. So the ceiling function is defined using math.ceil as you see here. So again, we pass the number that we want the ceiling for in between the parentheses. So what is the ceiling function? It gives you the largest, it gives you the smallest number that is greater than or equal to what we pass over here. So for an example, if I gave you 6.6 and I asked you, okay, what is the ceiling function for 6.6? It should give you 7, because 7 is the largest integral value that is greater than 6.6 or equal to it. Obviously, if you give the ceiling function for an integer, it will give you the integer itself. So let's look at an example, 7.8. So this should give me the value 8, as you can see here. Let's look at another negative number. So minus 12.3. An integer that is greater than minus 12.3 is minus 12, the smallest integer that is greater than minus 12.3, and this should give you 12, as you can minus 12, as you can see here. A similar function is the floor function, which is defined like this. Again, the floor function, what it does, it gives you the greatest number that is smaller than whatever value we pass between the parentheses. So if I gave it 2.3, it should give me the value 2. Again, if we pass integers, it will just give us the integer itself. Again, just to reiterate, this ceiling and floor functions, they give you integer values. So the floor function will give you the largest integer that is smaller than what we pass over here. So let's look at 6.7. So the largest integer that is smaller than 6.7 is 6. And as you can see, this is our answer over here. The next function that we will look at is the truncate function. The truncate function is defined using this. Truncate is very similar to what we have seen. This is how we define the truncate function. It is very similar to the ceiling and floor. In the truncate function, what we do is we pass a decimal value, a float number, to the between the parentheses, and what we get back is the number without the decimal component. So only the integral component. So if I gave it 7.8, for example, it will give me only the 7 part. It will return me only the 7 part, and it will chop away the 0.8 part. If I gave it minus 12.3, it will chop away the 0.3 part and give me only minus 12 back. So let's look at an example. 8.9. It should give me only 8, as you can see here. Say I did minus 8 or minus 6.9. It should give me minus 6. So you can think of truncate function as it does the floor function for positive values and it does the ceiling function for negative values, because it rounds down and rounds up respectively for positive and negative values. So now let's look at the next set of arithmetic functions. Let's move on to permutations. Permutations are defined using this. As you know, so in between the parentheses, I have to pass two values, n and k. So I have to pass an n and a k. The k has to be lesser than or equal to n, because the permutation, as you know, is the number of ways in which we can permute from n objects, k different objects. So what this mathematically, what this is permutation of n and k is n factorial divided by n minus k factorial. So if I pass, say, 10 and 6, it will give me the permutation of 10 and 6. So let's look at what's the value. As you can see, it's this very large value, 151,200. Similarly, there is a combination function, and this is combinations and permutations are used a lot in probability. So if you're going to move into that sphere, which you will encounter a lot in machine learning AI, you will be using these functions quite a bit. So the combination function, again, you pass an n and a k. Again, the n should be greater than or equal to this k. What this evaluates is n factorial divided by n minus k factorial times k factorial. So again, this is a mathematical concept. So let's look at the the combination of 10 and 6. So as you can see, it gives me 210, which is the combination of 10 and 6. In the arithmetic function section, are GCD and LCM. As we know, GCD is the greatest common divisor, LCM is least common multiple. So as of the newest version of Python, in Python 3.9, the math module gets these two new functions that were very lately added, actually. Since I cannot show you that because I don't have the absolute latest version of Python on my system, but using the math.gcd function, this is the function, and in between this, what we would do if we had the latest version is we would pass two numbers, or as many numbers in fact, and what this function would do is find the common divisor amongst them. So if I gave these, say for example, if I gave these numbers, it would give me the value 10. Similarly, the LCM function, again added in Python 3.9, finds the common multiple amongst whatever we pass over here. So if I passed, say, 20 and 30, this will give me the value of 60, which is the LCM of 20 and 30. So again, these are it's something neat that if say you have Python 3.9 or if you have Python 3.9 or after that, you will have access to these functions as well if you when you import the math module. So that was for the arithmetic functions. Let's move on to the next section, which are power and logarithmic functions. So let's start off with the power function. There are multiple ways you can actually do a power function in Python. So you can do something like this, which is the equivalent of 2 to the power 3, or you can use the inbuilt module math, and you can use the POW or the power function, this is how you do it. And if I had to do same 2 to the power 3, I would just pass 2 and 3 as arguments like this, and it should give me the value, as you can see, 8 over here. What if so there's actually one more function, which is simply the POW function, and this is not part of the math module. It's a function not part of the math module, but it's still part of the base Python. You can use this as well, and you can do the same thing. POW 2 and 3, it should give you the value 8 again. Now you might ask, what's the difference between these two functions? Well, it's not much. For at least in a beginner standpoint, it's not that much. Just note that the math.power function is slightly computationally faster than the simple power function. So yeah, moving on, the next topic would be the next function that we'll discuss is the exponential function, which is defined like this. Again, exponential function is again e to the power something. So if I did exponential of 3, this would give me e to the power 3. So as you can see, oh, of course, I did not define the module beforehand. So math.exp, now when I do this, it'll give me some value, which is basically Euler's number or e to the power 3. So this was the exponential function, and let's look at an example. So we will look at the example of rate of decay, and we will use the this function in that example. So the exponential rate of decay is used to calculate the amount of radioactive elements that is present in a substance after a certain amount of time. So the expression is something like the initial amount of radioactive elements that were present right at the beginning times the exponent of -693 times t for time divided by the time period, the half-life time. So let's just write it down to make it simple. So again, as you can see, so this will give me the remaining amount of radioactive elements, right? So let's write down remaining. Let's assign this to a variable remaining. So the initial, again, initial is the initial amount of radioactive elements. So let's give it some value, say 100. The time, let's assume it's 10 years. And let's say the half-life is around, I don't know, let's give some value, say 3 or something. Again, this is, the details are not important. So this will, I'm using the math.exponential function over here, as you can see. And for these values, now when I check what's the value of remaining after I calculated it, it's something. So it's basically what this tells me is that I started off with 100 units of some radioactive element. And in 10 years, this is what is left. So yeah, so this is how we would use, say, the exponential function in a particular example of ours. So next type of, again, functions are logarithmic functions. So let's look at some of the logarithmic functions that are part of the math module. So a basic log function would be written like this, math.log. In between this, I would pass the number that I want the log for. By default, if I just pass one number, it will calculate the log of 8 to the base of e. As we know, e is the Euler's number. So let's see what it does in this case. It gives me some value. What if I wanted to specify a particular base? Well, I would pass a second argument in this case. I want to find the log of 8 to the base 2, and this should be the value 3, as you can see over here. There are two specific functions that are also provided in this math module, that is log 2. What this will do is again I have to just pass one argument, and this will automatically find the value of the log of 8 to the base 2, as you can see here. Similarly, there is a math.log10 function. If I did this, I will find the value of something here to the base 10, as you can see. So this was logarithmic functions. Then finally you have the square root function. So how would we use the math? The square root function is math.sqrt. Again, we pass what we want over here. If we want the square root of, say, 49, this should give me the value 7, as you can see. Finally, maybe move on to the final set of functions that we can do using this math module. They are trigonometric functions and they are hyperbolic functions. So let's start off with some of the trigonometric functions. As we know, we can do sine, we can do cosine and tan, some of the basic functions. The way we would do it is math.sine. In between this, this is to calculate the sine of a particular angle. And this angle must be passed in radians. This is very important to note. We do not pass it in degrees, but in radians. So if I say passed sine of 3.14, as we know 3.14 is an approximation of the value pi. Sine pi is supposed to be, in fact, it's supposed to be 0. So let's see. We get something close to 0. Again, since this is an approximation, it won't give us the exact value. Similarly, we can use math.cos to find the value of a particular angle. If you want to find the value of the cos of a particular angle, we can use the tan function in case we wanted to find the tan. Similarly, we have the next set for arc sine and the arc cosines of angles. So to find the arc sine, for example, we would use a sine. For arc cosine, we would use this. And for arctan, we would use this. The next set would be hyperbolic functions. Again, hyperbolic functions are basically the sine and the cosine and the tan calculated not circles but on hyperbolas. Again, the details you don't have to know the details. You should know that if you wanted to say, for example, find out the hyperbolic sine of an angle, we would use math.sine h, and we would pass what we want in between this. Similarly, if we wanted to find the cosine, it would be cos h, tan, it would be tan h. And if we wanted to find the inverse of the hyperbolic inverse, what we would do is use a. So we would use a tan h. If we wanted to find the hyperbolic inverse of sine, we would use a sin h. And similarly for cos, it would be a cos h. In this video, we will learn about conditional statements. And we will learn about how do we create these control structures where we have these conditional statements. We will learn about the keywords that we use in Python to create a conditional statement block, the if keyword, the elif keyword, and the else keyword. We will also learn about indentation and its importance in Python. So let's get started. So the basic syntax, if you will, for a if statement in Python consists of the keyword if, followed by an expression, as you can see from this pictorial. There's an if statement, there is a expression, there is this block of code, which if you can actually see is slightly indented to the rest of the code. And then we have the rest of our code after that. So what we're looking at is this. So this is our if statement block. Now let's break this down. So what is this expression that we're speaking of? An expression in this context is a Boolean expression which evaluates to a true or false statement. So when we are speaking about the if statement, we have an expression, and if this expression evaluates to true, then we execute everything below the if statement. Otherwise, we skip that portion. As you can see, if the statement is true, we execute this statement or these statement blocks. Otherwise, if it's false, we move on to the next statement block or the beginning of a new statement. So let's look at an example to further understand this. let's take this if statement over here. As you can see, in this if statement, I have this expression 50 greater than 30. So what Python is going to do now is it's going to check whether 50 is greater than 30, and it's going to check it in a Boolean context. If this is true, then we can move on to the next portion, which is this. But if it is false, then we will skip this. So let's see what happens over here. So since we know that 50 is indeed greater than 30, this is a true expression, we move on to this block of code, which is saying that print 50 is indeed a larger number than 30. So let's see if this actually gets printed. So as you can see, we get this, the result, which is, this is a true statement, and we get our print statement getting executed. What if we gave a false expression over here? So let's look at what happens if I gave a false expression. Now I'm checking if 50 is lesser than 30, which is a false statement. So if it's a false statement, we do not move on to this portion of our if statement block, and we directly skip. So if I have to execute this, you will see nothing gets executed. And in fact, my print statement is just not executed because we never entered this, because our expression over here was indeed false. So yeah, this is how a basic if statement block looks like in Python, and this is how how we move on to how we check for the truthfulness or the falseness of a particular expression in the if statement. So moving on, let's move on to the topic of indentation in Python. So as you can see, this if statement is an example of a control structure. So without defining what a control structure is in detail, control structures consists of these conditionals or loops or iterations, if you will. So all of these control structures involve heavy indentation. So what does an indentation mean? Well, what if I gave you an example? Say I gave you some variable called age, and I wrote 20 over here. Now if I gave you an if statement saying if age is greater than 10, now it's very important to note that when I'm defining an if statement, I need this colon, otherwise this if statement is not defined. So this colon is important anyways. So now I'm checking this expression if age is greater than 10. Now what happens if age is greater than 10? Now what if I want Python to do something only if age is greater than 10? Well, how do I tell Python that there is a piece of code or a section of code that I want executed only if this condition is met? Well, this is where indentation comes into play. So if I want this line, this person is an adult. Again, this is some random line where I'm assuming age is pertaining to this adult, alright, or this person. So if I have this variable age where I write this number 20, which denotes the age of some person, and I'm doing a check if age is greater than 10. Actually, let's be specific here. Well, the adult age for most people is 18 in most countries. So let's see if age is greater than 18. Now, if I'm doing this check, I want to print this statement only if this person's age is above 18. So how do I tell Python that I only want this statement to be executed only during this if this condition is met? Well, this is where indentation comes into play. And as you can see, exactly as you can see, this portion of the code is slightly indented compared to the if statement. So when this condition is met, then only do we move on to this. If this condition is not met, we move on to whatever the next section of code will be, like whatever code that we have after this if statement. So let's see. So since this condition is actually met, as you can see, this print statement is actually executed. So this is the importance of indentation. Now we will see as we learn more about if statements and else statements and elif statements, how indentation plays a key role in defining what we want as an output when a certain condition is met. Alright, so for now, it's very important to understand that this is how indentation is used in Python. In other languages, we might use, we probably don't use indentation. In fact, popular language, the C language, does not use indentation at all. But some languages, and Python is probably the trademark language for indentation in programming. So you might say that, so different people have different opinions on indentation. The general consensus is that indentation helps make the code look very presentable and very readable, and this actually is one of the facets of Python programming, is the indentation and the easy readability of it. Anyways, moving on. So what if we have multiple conditions in our code or in our if statement block that we want to see? So let's create this list, or let's actually just copy this example that I have written over here. As you can see, what I am doing in this piece of code is I have a list X where I have this integer 50, I have two strings, cat and apple. Now I want to check a bunch of things. So I want to check if 60 is an X, and I also want to check if the string cat is an X, and I want a final sort of, like, if none of these conditions are met, I want something to happen. So how do we do that? Well, we start off our if statement block with the standard if keyword. Alright. Now if we have one more condition that we want met, then we can use the elif, which is kind of a short form for else if. So we use the elif keyword. So what Python reads is it checks this condition, then it will check this condition. And then finally we have this else keyword, and else is a keyword used in our block to tell Python that if none of our earlier expressions have been true, then do what is in the that is within the else keyword, that is indented within the else keyword. So again, we don't pass an expression for else, because else is we only reach this else statement in case all of the earlier conditions have not been met or have come to be false and not true. So let's look at this particular code example. So we have a list of 50, cat and apple, and my first expression that I'm checking is 60 in X. So this is how we check actually. So if 60 and X should be read as is 60 in the list X. So is this 60 in the list X? Well, actually no, we don't have the object 60. So this part is not executed. We move on to the next condition. Is the string cat in X? Well, actually it is. The string cat is indeed in X. So we move on to this statement block, which is within the condition that is met, which is print cat is in list X. And you will see that none of the other statement blocks will be executed because we have met our condition over here. So if I execute this, as you can see that the print statement cat is in list X is what is actually executed. And we do not execute this obviously because it is false, and we do not even check, or we do not even move on to this statement because, well, we have a condition met over here. So it's one thing that is important to note is that we can use as many elif statements to check for as many conditions that we want to check for, but it's very important that we only use, and if we are using, that we only use one else statement and only at the end of our block. Okay, so moving on. Now I'm going to show you a very neat example about how Python actually does its these condition checkings. So it's very important to note that once a condition is met, none of the other conditions are even checked for. So we do not even consider the next statements, and we directly leave this if statement block. So let's look at this example over here. Now in this example that I have over here is where I've stored the string cat in X. Now I have three conditions that I'm checking. I'm checking is 50 greater than 60. I am checking if the value of X is indeed cat, and I'm checking some random expression 1 divided by 0. This is not even a check. This is literally just checking if 1 divided by 0 is true or false. And as we know, we cannot divide anything by 0. So let's see what happens when I execute this statement. Now typically if I wrote 1 divided by 0, Python will throw me an error because 1 cannot be divided by 0. That is an erroneous statement. So let's see what happens when I do this actually. As you can see, I have a statement being printed, but I have no error even though I gave an erroneous statement in 1 divided by 0. Well, now you might ask, why is that so? Well, it's simply because I have actually never reached this condition. I have not even, Python has not bothered looking at this, because if you actually see, there is a condition previous to this over here, which is met and which is true. So we move on to this block, we execute this block, and we forget about the rest of the code. So we don't actually get to this erroneous statement, which is an interesting thing, and which is an example that I have shown to show you that once a condition is met in an if statement block, we do not look at any of the further conditions that are being checked. Okay, so finally, I have one small topic that I would like to share with you is the conditional expressions, or the Python's ternary operator. Now, this is slightly different to the if statement that we have talked about up until now, in the sense that it is not a control structure. So what this actually is more of an operator that defines some expression. So let's see what I am trying to say over here. So as you can see over here, highlighted is the syntax for what I'm trying to talk about, this ternary operator. So let's look at this example and let's see what I'm trying to do over here. So I have this variable age, alright, and this age is 26. Now just read this statement. X is equal to adult if age is greater than 18, else child. Now I could have done an elaborate control structure with an if statement, then an indentation within that if statement, and then I could have written else and then another indentation, and I would have written another statement over there. But instead of that, I've used this operator to assign a particular value to the variable x. And this what value I'm assigning to x depends on if this condition is true or false. So as you can see, the condition says is age 18, greater than 18. So if this is true, then I assign this particular string. If it is false, then I go on to the else statement and I assign this. So since age 26 is greater than 18, I should assign the string adult to x. And as you can see, if I execute this and check what is an x, you can see adult is indeed an x. So this is a very neat, a very readable, and a very it's a better looking way to perform simple else, simple if and else statements where you don't want to create a whole if else statement control structure block. So yeah, this was the ternary operator. Finally, we make a short note on the pass statement in Python. So the pass statement or the pass keyword is a place where is a placeholder of sorts. So what if I had an if statement and I'm writing a piece of code, but I don't know what to do with this if statement. So if a statement is correct, if a statement is true, but I don't know what to do if this statement was true, how do I tell Python, well, let's just keep it a hold for now, and I might put something into this block later in the future? Well, I would use the pass statement. So if I had this, say this some condition again, if I'm checking age is greater than 18, but I don't know what to do with this, I would just simply use this pass statement. And this basically does nothing. It's like a way to create a placeholder where maybe in the future I might write some sort of a print statement or some sort of a different function or something else within this indentation. So, but in the meantime, like currently I don't have anything to place over here, so I just leave it with a pass statement. So this is a way where you can use a pass statement in if and else statements or if and else control structures. In this video, I will introduce you to the concept of iterations in Python, and we will be speaking in specific about the indefinite iteration in Python, otherwise known as the while loop. So let's look at what an iteration means. An iteration is executing the same block of code over and over, potentially many times. A programming structure that implements an iteration is called a loop. Now in programming, we have two types of iterations, definite and indefinite iterations. And in this example, we will be speaking about indefinite iterations. Indefinite iterations in Python is the while loop, where we use the while keyword to define an indefinite iteration. So let's look at the basic syntax. As you can see, this is the basic syntax where we have the while keyword followed by an expression and again the colon, and below that is something indented. Again, we encounter indentations just like in if-else statements, a set of statements where what happens here is, following the while keyword, we have this expression where this expression is evaluated in a Boolean context. Again, we check if this expression evaluates true or false. And if it is true, we execute all the statements or the statement block that is indented below this while statement. This is another example of control structure, much like if and else statement blocks, where we use a lot of indentation. So let's look at a basic example now of while loop. So let's copy this example and let's see what this does. So I have a variable n where I am assigning it a value 0. This is called an initializing process. And it's very important to note that most while loops consist of an expression which contains a variable, a control variable, which is usually initialized prior to starting the loop. And then this control variable is typically modified somewhere within the main loop body. So in this case, my control variable is n and I am initializing it by assigning it the value 0. So let's move into the loop now. So the loop has this while keyword, as you can see, followed by an expression n lesser than or equal to 5. Now what this is an expression which is going to check if it's true or false. Is n lesser than or equal to 5? And as long as this expression is true, we will continue doing whatever is indented below this while statement. And what is below this while statement is a print statement, first of all, which says value of n is, and it basically prints the value of n in that particular iteration. And as you can see, this compound assignment where we add the value of n by 1 and we assign it back to n. So what this is, let's see what this does actually. Let's execute this and see what this does. Important to note, the value of n again is initialized at 0. So this while loop will keep going on until the value of n remains lesser than or equal to 5. So as you can see, I have the execution of this particular block of code or this while loop where I get the multiple different iterations of this print statement that you can see here. The first iteration, it says value of n is 0. Then it says value of n is 1. What I'm doing is I'm writing the value of n multiple times, and each time the value of n is written over here based on what iteration it is. So what is happening actually is that initially the value of n is 0, and I print the statement value of n is 0. Now I add the value of what is in n by 1. So now what is the value of n? So again we do this check. So after this first iteration, we come back, like once this whole block of code is executed, we again come back to this expression and we again check if this statement is true. So now that the value of n is actually 1, this statement is still true. So again we execute this, and that you can see over here, value of n is 1. Now again we add the value of n by 1, and again we go back here once this block is executed, and we check if this statement is true again. And as you can see, the value of n when it's 2 is still making sure that this expression is true. And this keeps happening until the value of n is greater than 5. So once the value of n becomes 6, this condition is no longer met. And finally, we do not execute this statement because this expression evaluates to false. And we do not do this anymore, and we finally leave our while loop. So let's check what the value of n is just to confirm this. As you can see, the value of n is indeed 6. And that is why we have left this while loop over here. So this is an example of a basic while loop where we check for this an expression. If it evaluates to true, we evaluate everything within it. Once this is done, we go back and we evaluate this expression again. If it is again true, we again go back and do whatever is indented within it. And we keep doing this until the expression gives us false. And interestingly, we don't necessarily have to define these control variables always. We can actually use iterables, and we will learn about iterables actually in a future video. But we can use iterables, and an example of an iterable is the list. So let's look at this list and let's look at this whole block. Alright, so I created this list A, which contains 5 objects, 1, 2, 3, 4, and 5, all integer objects. And I have another variable x where I store the integer 1. Now this while statement, now it might look confusing. Now it says while A. Now what is A? Well, A is not your typical expression where you're making sure if some condition is being met or not. But this, the way you read this is while A exists. So in the context of a list, as long as A, which is a list, contains objects within it, A is true. If it does not have any objects within it, A is false. So while A, basically what it means is while A has objects within it. And if it does have objects within it, or as long as it does, we continue executing whatever is indented within this while statement. And this while statement is a print statement. Again, we we have this value x where we're doing we're printing this is iteration number, and we pass x. So the first iteration will obviously pass x is equal to 1, and then we add x by 1, and then the second iteration should pass this is iteration number 2, and then so on. And finally, we have another statement within this block called the pop statement, where we're popping the elements of A. Now, as if you would have seen the video on lists, the pop statement removes the rightmost value from a list. So if I do a.pop, initially it will remove 5 from this list, and I will have the rest of them. Again, if I do pop, it will remove 4 from this list, and then you will have the rest of these. So let's actually see. We'll actually check what's left in this list each time we do this pop statement. So I'll also print the list A during each iteration, and let's see what happens over here. As you can see, what is happening out here is while A has elements, we are going to continue doing this while statement, whatever is within it. So in the first iteration, obviously we have all of it, and it is iteration number 1. And as you can see, the list contains everything. Then I pop it. Then iteration number 2 it again has elements, but it has lost its rightmost element. And this keeps on happening until the list finally has no elements left. And once the list has no elements left, this expression while A evaluates to false, and we do not execute this anymore, and we leave the while loop. And again, let's check what is in A. A should have no elements. As you can see, it's an empty list. When I checked what's in A, it's an empty list, and that is why while A returned me a false, and we did not print any further. So this is an example of using a while statement using lists. And of course, the next topic would be discussing nested while loops. And this is a broad topic. What I mean by this is that when I'm saying nested while loops, I'm actually talking about nested control structures. So we can have while loops within while loops. Not only that, we can have if and else statements within while loops. We can have while loops within if and else statements, and we can have if and else statements within if and else statements. So if you think of all of these loops, and we will even speak about for loops in another video. For loops again are a type of control structure. So all of these are control structures. While loops are control structures. For loops are control structures. If and else statements are control structures. All of these are control structures, and nesting can happen within them, and it does not matter which is the parent of the nest and then the child of the nest. You can have a while loop within an if and else statement. You can have for loops within a while loop. All of this is valid in Python, and it's one of the great features of Python that is very flexible in this way. So let's look at an example where I have a while loop within another while loop. So I'm copying this piece of code where I have this list 1, 2, 3, 4, 5, and another list first and second. Now my first while loop, I print what is popped from A. So I take A, then I pop the 0th index. So basically from the left hand side, and I print what is that. Alright. And then I have another while loop where I have this list B, and I'm doing the same thing. But this while loop is within the first while loop, and let's see what happens out here. So as you can see, my first iteration of this parent while loop causes me to pop what is the first element, which is 1. Then I do these while loops, and this is completely executed, and only then do I go back to this first one, and then I come back and do all of this again. Then I go back to this one, and then I come back and do all of this again. And that's why you can see this repetition. So I have this first iteration, and then I do the second while loop. Then I have the second iteration, and then I do the second while loop, and I keep doing this. And this is an example of a nested while loop. Okay, so our next topic in this video would be break and continue statements. Now break and continue statements are ways to abruptly end iterations in a particular loop. You can use break and continue statements not only in while loops, but you can use it also in for loops. So let's look at how we use it in while loops. And let's look at what we mean by break and continue statements first of all. Well, the break statement terminates the loop entirely. So once the break statement is found, the complete while loop that we are using is completely terminated. And the continue statement, on the other hand, terminates only the current loop iteration, and it goes back to the beginning or the expression, and it checks whether the expression or the controlling expression is again reevaluated, and it is checked whether the loop will execute again or terminate. This pictorial that you can see here actually emphasizes, or it shows the difference between break and continue. So I have this while loop and I have an expression. Alright, I have a bunch of statements, and I have a break command over here, and I have a continue command over here. So if I encounter the break command, it will not execute any of this. In fact, it will not execute this while statement at all, and it will move on to the next piece of code that we have. But a continue statement, if a continuous statement is encountered in a while loop, will not completely break away, but it will not execute the rest of the statements in that iteration, only these two, but it will go back here, it will check this expression again, and again we will do this all over again. So this is this small difference between the break and continue statements, but both are used to abruptly end an iteration in a loop. So let's look at an example of how we use the break statement. So I will use this example where I have initialized some controlling variable n to 0. My first loop will check whether n is less than or equal to 5. If this is true, then I will print this statement. Then what I'm doing over here is I am incrementing it by 1. Now in my earlier example using the similar example, I had no, this part was not there. So what you got was I was printing the value of n. So it was printing as like value of n is 0 and then 1 and then 2 and then 3, 4 and 5. But over here I've included I've nested an if statement, and within that I put a break statement. And this if statement is checking if n is equal to 2. So once n is 2, I move on to this and I do the break statement. So let's see what happens now. As you can see, so when I've executed this, I don't get the whole value of n is 0 and then 1 and then 2, 3, 4, 5. I stop at 1, and that is because once n is equal to 2, I actually do not execute this while loop again. I do not go back and execute print value of n is 2 now. In fact, I break from this whole while loop, and my while loop terminates right then and there. And that's why you only get these two iterations, value of n is 0 and then value of n is 1. Okay, so now I'm going to show you a neat example of what happens, or what is the difference between a break and a continue statement. Okay, so let's go back to our initial example where we're printing this value of n is 0, 1, 2, 3, 4 and so on. But I've added one more statement where I print hello at each iteration. So let's see what happens when I do this. As you can see, it will print hello after each of whatever I was doing already. Now let's introduce our break statement first of all. So when I do break, well, let's go back to this if statement. If we check this condition, then we break. Let's see what happens now. As you can see, something interesting has happened where we have this first iteration completely being executed, but the second iteration kind of stops where there's no hello, and that is because we have broken from this while loop before the second iteration's hello was printed. Let's see the difference between a break and continue now. So now I have this continue statement instead of a break. Let's see what happens here. As you can see, it seems familiar to our first example where we did not have any break or continue. But there is a small difference that I want you to catch, and that is very important about this continue statement. So as you can see, the first iteration has value of n is 0 and then hello. Then value of n is 1, but there is no hello. And this is because once this condition is actually met, we do not move on to this statement, but we go back to this expression and we evaluate this expression. And then once we evaluate this expression again and it's found to be correct, we do everything the same again where we print hello. But except for that one step where this if statement was met and we did continue, and this following statement was not executed. And that happens only for one iteration, and that is when n is equal to 2. And as you can see, that is what happens over here. In one of the iterations, we miss a hello, and that is the difference of the continue statement with the break statement. This video will be an extension to that topic where we will be looking at 3 examples where we are using while loops along with other stuff like say if and else statements. So our first example will be where we calculate the factorial of a number. In this example, as you can see here, we are first going to ask the user to enter a particular number for us. Now this number is supposed to be an integer. Once we have this integer, we store it to a variable called number. Now we have this, you can say this variable called FAC which stores 1, and we will see how we are using it later. Now we know that the factorial of 0 is 1. That's how it's just defined. So we have an if statement checking whether our entered number is 0. And if it is 0, we say that the result is 1 or the factorial is 1. However, if we enter a number that is greater than 0, we must calculate the factorial for this number. And that is what we are going to do in this else statement block over here. Now in this else statement block, we have a while loop. In this while loop, the condition is checking while number is greater than or equal to 1. So as long as this condition is true, everything within that while loop will be executed. So as long as number is greater than or equal to 1, we are going to execute these 2 lines. Now what do these 2 lines do? Let us see. So the first line takes the variable FAC where we had the number 1 stored, and we are going to store FAC times number into it, number being the number that we have inputted. So in case, for example, we entered 8, then what this line will do is 1 into 8, and it will store that back into FAC. Now once that is done, we move on to the next line where we are decrementing the number variable by 1. So if we have stored 8 or we have entered 8 into our input, it will become 7. Now as we know, 7 is still greater than or equal to 1, so this condition is still being met. And then we do this process again where we are going to multiply FAC. This time FAC stores the value 8, and we multiply it times the new number, which is 7 now. So we do 8 into 7. And then again we decrement this Also, once we do 8 into 7, we store it back into FAC. And we keep doing this, where we keep multiplying 8 times 7, and then we decrement the number variable by 1, and then we check this condition again. So what ends up happening is, we are going to keep doing 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And once we are at 1, again when we do this decrement operation, the number variable will store the value 0, and then this condition will no longer be met. So number will be 0 and this condition will be false, and we can move out of this while loop. And then finally we store the result into a variable called result, which stores the result of 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is of course if we did enter 8 when we were asked to give an input. So let's see this in real time once we execute this. So I'm executing this. The first thing it asks me is to enter a number. So let's say I enter my number 8, as I was speaking about 8. Alright, now that I have entered 8, as you can see, the result that it gives me is factorial of 8 is 40320, which is correct, and you can check this for yourself, where it will show you 8 times 7, or 8 factorial is basically this number. Okay, so now in our next example, we will be looking at how we can generate Fibonacci numbers. For this example, we will be using bunch of if and else if statements along with a while loop. So let's look at